Welcome back, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers. And we're here today for day 2 of the free Azure Solution Architect Expert Training. This is going to prepare you for the Azure Solutions Architect Expert Certification. So if you ever desire to be an Azure Solution Architect, well, we're training you for it today. Some people are preparing for the AZ303. The AZ304 or the AZ305, this will help you with any of the certifications, that Microsoft Azure certification. This is free Azure training, and it's a free Azure course for the AZ305 exams. It's compliments of Go Cloud Architects and Go Cloud Careers. We want to do everything we can to help every one of you get cloud hired. That's what we do. It's all about getting cloud hired, and more cloud hireds. Many of you know me, that I've been working in tech now for 25 years. I was an architect at WorldCom, which is now Verizon, an architect at Comcast, an architect at Cisco, and an architect on Wall Street. It's been a fun and a storied career. And I want you all getting cloud hired, cloud promoting, and having your best cloud careers. And that's why we do it all. It's all about building cloud careers. So, I want to go over a few things. If any of you missed it last night, please, it's so important. Go back and watch the free session last night. Last night, we brought in a 21-year-old, and he's an amazing kid, with no degrees and no experience, who just got his first cloud architect job, and he's going to tell you exactly how he did. So if any of you desire to be cloud architects, we'll pop the link to that free thing to see in the chat box. I want you to watch it. Now, I'd like to tell you all about something special we're doing for the cloud computing community. If you want to get hired, now's your time. We know the economy is terrible. We know inflation is horrible, and I want to see you all maximize your salary, maximize your career opportunities, and get cloud hired. So currently, we run a 30% discount off of all of our courses. Use the coupon code POTENTIAL. Now, I won't be talking about our training throughout our session. I'll be talking about what we can do in our training together. This will be technical things. But if you want to get hired, listen to what other people are doing. Watch how they're getting hired and see that free session from last night so you understand. And sign up using coupon code POTENTIAL. Now, let's talk about some things that I want to do some housekeeping to make sure you guys know we have the best second day of the Azure Solution Architect Expert Training, because this is free Azure training, and it's an AZ305 free course. So let's talk about the labs. All of you know that I am obsessed with getting you cloud hired. I'm obsessed with cloud hired. I'm obsessed with cloud hired. So people hire you based upon the knowledge that's in your head. Do you understand the tech? Can you explain the tech, how it works, why organizations can use it? That's why they hire you. So I still want you to get hands-on experience. So I've got a series of labs for you. And guess what? You can do them on your own time. They're completely free. So sign up for the free complimentary labs and do the hands-on tech on your own time. Nikhil from my team will do a marvelous job demonstrating how to configure these things. So subscribe to the free labs. They're completely free. Go subscribe to them. And we'll get you high, so that'll get you more experience. The link is in the chat box. Now next week, more free to help you get hired. Here's what we're going to do. We're going to have a subnetting and a BGP workshop. The cloud's nothing more than a network at a data center that's been virtualized, and most people don't know the network. So I'm going to give you some critical skills. And no, I didn't just take an AWS networking certification and think I could teach networking. I'm one of the original Cisco certified internet experts. My number is 7417. Back when it was a hard 2-day exam before Cisco made it easy because too many people are failed. I taught networking to people at Cisco, at Comcast, at WorldCom, on Wall Street, you name it, I've taught it. And I like to teach you to get you all cloud hired, cloud promoted, and cloud paid more. So join completely for free. We're going to do it on YouTube to help you build your career. Tomorrow, we're going to have our famous How to Get Your First Cloud Architect Job webinar. And it's going to be live on Zoom. It's going to be a party time. Come join this webinar and you will learn how to get your first cloud job. And I'll tell you the cloud architect, cloud engineer, if you desire as well, because they're different careers. And I want you all getting cloud hired. So come, I'll tell you how to leverage your life experience to show the hiring manager you have experience when you do not. I will show you exactly what the hiring manager wants. I will go over the cloud architect well explicitly so you know everything about the career. So you can master the skills for your career, not somebody else's career. You get a cloud hired. I will tell you what to do on your resume. I will tell you how to skip those pesky HR people that want to block you when you don't have experience. I'm going to help you with all of it. You'll either train with us or train on your own. You're going to know exactly how to do it. I want you cloud hired, and it's completely free. So join us tomorrow. Now, see, all this stuff that's free, it's for you all to better yourself. Now, let's talk seriously for about a minute. We spend a lot of money at Go Cloud Architects and Go Cloud Careers to produce free content. There's free Azure Solution Architect expert training, free Azure Training, AZ305 free courses. To put a course together like this with my team of all MBAs, plus we've got 3 MBAs and 3 other people to put this together, it costs as much as buying a car. And I'm not joking, it costs at least that much to buy a car. I'm in a $75,000 recording studio right now just to stream to you, to make the quality good. And we do this because we love the cloud computing community, the cloud architect community, the cloud engineer community, and we want you all. Could you help us share our mission of free training? We spend a fortune to try and educate others. I do it personal money because I want to help everybody. Could you all make, and help me out, a 30-second LinkedIn, Facebook, or Twitter post, and invite, or an email that we copy a bunch of people? Can we take 30 seconds to 1 minute to invite your friends to this free training? Like I said, it cost us as much as a car to produce this free training, and I want to maximize who gets to see this. So please, everybody, can you make a quick tweet, a quick Facebook post, post it in a group? I don't care. Make an email, invite 5, 10 of your friends, but please make a quick social media post for 30 seconds to a minute. We'll give you all a minute. Help us help more people. I spend a fortune trying to produce this kind of content to help others. I spend a lot of time doing things for free. Chris on my team is working hard. Chow on my team is working hard. Eddie's working hard to make this happen. I got to tell you right now, he's working real hard. Leo's working hard. Alonzo's working hard, and I'm working hard. So please make a social media post and share it. Provide a link to the free training. Help us share free. We're not asking you to help us sell our paid products. We're just saying we spend a lot to do it to help the world. Please help us share our mission. Heck, be done. Share our free ebooks, the links to the free ebooks. Share our free CCNA training. Go ahead and do it. For our free Azure Solution Architect Associate course, or book, I don't care. Share our free AWS Advanced Networking, but share it. Invite your others to this free training because we want to help everybody get cloud hired. So give about 30 seconds for that to kind of help us about. While you're at it, give me a hashtag or that says cloud hired and cloud architect or cloud engineer. And also when you're done that, tell me where you're located while I wait for you guys to all make a social media post. I'm in Port St. Lucie, Florida today. I know lots of you guys are all over the world. If you guys do that, and then they're out. So give me a hashtag Azure is even better. Hashtag Azure. Phoenix, Arizona, I'm seeing. Cloud hired, I'm loving this. Can we put the LinkedIn link in the chat? If you make a LinkedIn link, almighty, and you want others to click on it, sure, pop the LinkedIn link on the clock and we'll all like and comment on it. Don't forget to hit the like button on this video, but please, everybody make a quick post and tell everybody to join the free. Cloud hired, Omar. Alex, Posisa, Chow, help us help more people. That's our whole goal, helping as many. Mozambique, I'm loving this. Nebraska, Lagos, Nigeria, I'm loving this. Sacramento, California, Las Vegas, how wonderful. UK, Berlin, loving this. See, we're all over from all over the world. And that's why we do this. And that's why we Tampa, Florida. I know that place real well. Ghana, Philip, fantastic. Let's like it like the bottom team. Yes, I got it. I love it. Washington, D.C., Katy, Texas, Atlanta. Seriously looking at this. Sao Paulo. We're everywhere from Ghana. I was in Canada from way of Nigeria, obviously, Austin, Texas, Zurich, Switzerland. I mean, seriously, this is about as good as life gets. Shared and liked so much. Thank you so much. I really do. I like to make our free content available to the world, and I'm very keen on getting it out to as many people as we possibly can. So Netherlands, see it everywhere, and that's why we're doing this. We're Lagos, Nigeria. I love this. California, Germany. Seriously, we're everywhere. So the way we're going to have fun today is going to be as follows. I will talk about the technology for about 20 minutes. We'll open it up for 10 minutes of questions. And that's what we're going to be working on. We're going to be starting with getting your data to Azure. And then we're going to build, and it's going to be lots of fun. So welcome everybody to the next day of Azure Solution Architect Expert Training, free Azure training, and an AZ 305 course. Okay, so let's get into data and getting our data to its location. We're going to start by talking about the Azure. Actually, before we get to that, we're going to start talking about Azure Simple Store. And what is Azure Simple Store? It's a type of cloud storage. It's kind of a hybrid cloud storage. And Azure Simple Store is really designed and optimized for storing, accessing, and managing large amounts of data. And it's pretty much an all-inclusive integration of primary, backup, and snapshots, archive. And it's really for an offsite storage solution. And it's used for backing up your data or offloading infrequently accessed data. And we can use storage for snapshots or disaster recovery. Let you know a little bit what this looks like from an architectural perspective so you can see it. Let me show you what it looks like graphically speaking. Amazon Azure Simple Store is quite simply, you've got your office or your offices, and you've got something that acts sort of like a virtual storage gateway, and it enables you to back up your content and send it to Azure. That's all it is. It's very simple. Azure Simple Store. It's a way that you can store your data from your data center in the cloud and make it look and feel like it's local. Excellent way to do some backup. Now let's get into some meatier topics that are a little heavier duty. We're going to start talking about the Azure Data Box. And I want you to think about it this way. If you have enough time and you have a network connection, you can send as much data anywhere, anytime that you desire. Anywhere. Seriously. So if I've got a 100 gig connection, I can send a lot of data. On a 10 gig connection, I can send a moderate amount of data. On a 1 gig connection, I can send the data. Now here's the thing. If I have a 100 gig connection, network connection versus a 1 gig, I can get it there 100 times faster. Makes sense, right? Well, what if I've got an enormous amount of data and I don't have multiple 100 gig connections and I've got petabytes of data, lots of data, and I have maybe a slow VPN or a gigabit Ethernet connection, and I've got to put a petabyte of data. Well, if we've got years to do it, that might work. But what if we don't have years to do it? Months to do it? What if I need to get your data to the cloud tomorrow or next week or 2 weeks from now? That's when we start getting into creative solutions for organizations that don't have lots of network bandwidth. You got a big enough network, this is irrelevant. If you've got enough time, this is irrelevant. But you got to move a truckload of data overnight or in a week. This is what we're talking about. And these are the Azure Data Box solutions. So we're going to talk about different Azure Data Boxes. So if any of you guys are AWS people, you're dealing with snowballs, snowmobiles, import-export services, it's the same thing. It's transfer devices. That's what we're talking about. So let's talk about the Azure Data Box. What is it? Quite simply, it's a hardware computer, a ruggedized computer with rugged casing that's filled with hard drives. It enables you to move large amounts of data from your data center to the cloud because you ship it over. Simple stuff, right? It is. So data boxes are designed to move immense amounts of data in short periods of time. So lots of data, real short. Otherwise, we just send it over our network, our VPN, our private line, our software-defined networking, et cetera, et cetera, et cetera. So now you know the why. It's always about the why. Now, when you what happens is they ship you this computer over the network, you transfer your data to it, it gets encrypted on it, and then you ship it back. to Azure. In today's world, they got to tell you, hey, they sterilize it between users, but they clean it between users. They pull your data off and they erase your data so that nobody else can see your data. Excellent data transport solution. And when we're dealing with the Azure Data Box, well, of course, there's going to be lots of versions of it. There's going to be the Data Box, and we'll talk about what that is. We'll talk about the Data Box Disk, and we'll talk about what that is. Now I'll talk about the Data Box Heavy, which is pretty cool stuff, and then we'll talk about a Data Box Gateway, which is something very different. So let's begin with the Azure Data Box. Think AWS, Snowball. It's a big, ruggedized, powerful computer that if you drop it, doesn't fall apart because it's shipped. And in unformatted capacity is upwards of 100 terabytes. But you gotta remember, you format these things and you lose some. So here's what happens. You get this big, ruggedized computer. It's got like a 10 gig Ethernet port. You copy your data on it. You call the company. They ship it back to Azure, and it's there. And then when Azure gets it, they take it off and put it into their object storage, and then you move it to wherever you want it. Simple, 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 right? Just like an AWS Snowball. Why are you going to use it? A lot of data, short period of time. That's it. What if you've got 250 terabytes? You might need 3 of them. It's okay. But you buy them, copy your data, ship it back, and the Azure staff puts it in storage where you can access it. Simple, elegant, timely-based solution. Now let's talk about the Azure Data Box Disk. It's designed for a one-time migration, designed to move a fair amount of data, that it's a little smaller. If you want to move, say, 40 terabytes of data to Azure in less than a week, you're using the Azure Data Box Disk. Moderate amounts of data. Again, it's ruggedized. Imagine me shipping you like a hard drive that's like my phone, and it gets dropped. Would not be the best thing in the world, right? Of course not. So, the ruggedized system, copy your data to it, secures it with AES 256-bit encryption, ship the box, they receive it at Azure, they put it in object storage, and you get access to your data, and all is well. All is well. So that's what we're dealing with, the Azure Data Box. Now let's talk about the Azure Data Box Heavy. This is pretty cool stuff to me. So let's say you got a ton of data, like a petabyte of data, and you don't have the time to ship it over the network. So what you have is Azure's got a Data Box Heavy. It's like an AWS Snowmobile, a little smaller, but it's like a Snowmobile. This thing's got a petabyte of storage capacity, but like I said, you got to format this stuff. So by the time you're done with the petabyte, you get about 770 terabytes of usable capacity. But the point is it's suited for huge amounts of data where your network bandwidth is insufficient. It's ruggedized, it moves back and forth, large data. So huge amounts of data, Azure Data Box Heavy. So let's look at what the whole process is with these Azure Data Boxes. And then we'll go into the next version. So in this graphic that I'd like to show you, here's the process. You take your data, and you ship it, whether it's a Data Box Disk, a Data Box, or Data Box Heavy, and it gets shipped over to Azure. They pop it in, and you can access it. The alternative would be, which we're going to talk about next, is the Azure Data Box Gateway. Okay, so let's say this is our data center. We're going to copy it to this virtual appliance, which we'll talk about, and then I'll automatically, or just dynamically, asynchronously copy your data from this Data Box Gateway to the cloud. And we'll talk about that next. But I just want you to understand the concept. So what is the Azure Data Box Gateway? Well, it's this. It's a virtual device that resides in your premise. You write data to it like a normal server, and it just copies it for you to Azure. It's designed for continuous data ingestion. It gives you good performance. And you can do a bulk transfer and then use it for synchronization. So let's really talk about what that looks like. I'll even whiteboard it out for you because I feel like this concept is important. So let's go draw it out. And in here, let's do the following. Let's say we've got you in your data center. Here you are. Here's your data center. Let's make you smiley because I love data centers. Oh, let's not even try and do that. Actually, okay, so here's the happy data center, okay? We'll put data center over here. Now you got over here on the right side, let me try and, over here you got Azure, right? Now, what you're really doing over here is you're basically putting a virtual machine. And this virtual machine looks like a server. So how do you connect to a server? Well, generally speaking, you use server message block if you're dealing with Windows, NFS for file storage if you're dealing with Unix or Linux systems. You can use iSCSI, whatever. So here's what happens. Your data center servers, what they do is they mount a server and they pretend it's a local server. And they connect it to this virtual machine that's your data box gateway. So we'll call it data box gateway. And what happens is you copy the data here, and then it just automatically puts it over there in the cloud for you. And it'll be sitting in your object storage in the cloud. And that's realistically all that's going on with the data box gateway. But I just wanted to kind of make that kind of clear for you. Next thing I'd like to talk about while we're dealing with these things is Azure Stack Edge. And what's this? This is basically a cloud storage gateway that enables you to send your data transfers to Azure while keeping it local. So it's kind of a back and forth transfer appliance. It's designed for storage, hardware compute, and network accelerated machine learning, etc. It's basically an edge computing and storage device. And that's all we really want to talk about from this section. Now, I'd like to go to the next section, but before I do, I think we've talked for about 20 minutes. So it's time to answer about 10 minutes of questions, and we'll go to the next concept. So are there any tech questions on what we talked about so far? Again, I hope some of you guys went out there and made some LinkedIn posts, some tweets, and invited some people to the free training. And if there's any questions, let me know. Otherwise, I'll get back to the content. Any questions in the audience about what we just covered with regards to data transfer devices? I give you guys a minute, and I'll probably sneeze due to the allergies because I have this beautiful little cat that I'm allergic to, but she sleeps with me every day. Excuse me. I have this beautiful cat named Cindy, but I'm highly allergic to her, but she's the cutest little girl in the world. And thank you so much, Alonzo. Can the data box gateway be used as a backup solution? Absolutely. You could have all your data in the data center and use the data box gateway to just aggregate and back up your data in the cloud. Absolutely. It's a perfect backup system. What did you say you would use a gateway instead of the data box? So cool, dude, here's what it is. Here's the data boxes. I copy the box and I ship it over. Now, the gateway is something different. The gateway is I put in my data center and I copy the things to the gateway and it automatically copies it over the network. So if I've got a little bit of data and a fast network connection, I'm always going to use the data box gateway and I'm going to send it over my network. But if I've got a lot of data and maybe my network's congested and I don't have the space in the network, or I've got a petabyte of data and a week to get it there in a 1 gig Ethernet interface, it's not fast enough. So keep that in the back of your mind. We're using the gateway when we have time. We're using the data boxes when we need speed because the network performance isn't fast enough for the amount of data or time that we have. Great question. You would use a data box heavy when your WAN is insufficient. That's exactly. So you kind of have it the exact opposite. You would use a data box when your WAN is sufficient. But when your WAN is insufficient, that's when you use data box instead of the data gateway. Because if you've got a 100 gig network connection, you don't need to ship data. You can just send it over the network. But if you've got a 10 meg Ethernet connection or you've got a 1 gig connection that's 80% congested, and you've got only 200 megs left, you can't fill it up. And you've got 100 terabytes to transfer, you don't have enough WAN bandwidth to get it there in a reasonable time. That's why we use the data boxes. Good question, though. Exactly opposite, though. I don't even understand your question before setting up this. Do you have to set up a tenant? Are you talking landlords and buildings? I don't really understand what you mean. So, but let's move on, Chris. What are the volume capacities of each Azure box? I can go over them again, no big deal. We talked about them, but we'll go over them again. So the data box heavy, Azure data box, goes upwards of 100 terabytes. So the Azure data box disk is 40 terabytes after it's formatted. The Azure data box heavy is 770 terabytes after it's formatted. And like I said, the main Azure data box is 100 terabytes unformatted. Good question. Angela, we cover how to choose physical storage versus network transfer. Maybe important to architects and engineers. Absolutely. So let's think about it right now. And I don't have too much time to cover this, which I would normally do in my Cloud Architect Career Development Program. But let's say, for example, you have 1 terabit. You have a 1 gigabit Ethernet link to the network. And nobody's using it at all. It's completely empty, which never is the case, Angela, but let's take that. So a gigabit per second, so let's take 1,000 megabits per second, and we have to divide by 8 because there's 8 bits to a byte, which means in a gigabit link, we can transfer 125 megabytes per second. So then we can say over 60 seconds, we've got 7.5 gigs that we can transfer on a 1 gig link. That sounds pretty high. So let's do 1,000 divided by 8 equals 125 megabit times 60, which gives us 7.5 gigs, times 60 minutes in an hour gives us 45 gigs in an hour, times 24 hours a day. So we can potentially, on a gigabit Ethernet thing, transfer 1 terabyte, realistically speaking, in a day's time. That sounds a little short, but a couple terabytes per day that we can do on a gigabit Ethernet link. Let's just keep it to that. Now, if I've got 1,000 terabytes of data and I can do a few terabytes a day, if I have 300 days to get it there, it would be great. But if I only have 10 days, that's when I have to use one of these data boxes. So, Angela, if I've got 100 gigabit Ethernet link, and if I really think about it, 100 gigabit, okay, so 100 divided by 8, I'm still able to transfer, a terabyte very quickly. So the point is if you take your network bandwidth, divide by 8 times 60 seconds, because that'll give you bits per byte, times 60 seconds to a minute, times 60 minutes to an hour, times 24 hours a day, you're going to figure out the max throughput on your Ethernet link. Now, having said that, max throughput on your Ethernet link, here's what's going to be going on. That's your max throughput on the link, right? Okay. So now when you're done your max throughput on the link, you got to add overhead for TCP IPs and then take away at least 10%, so you even lose more. So, Angela, it's about if you've got a lot of data in a short period of time, you're using the data boxes. If you've got a lot of network bandwidth, you're using your gateway. And if you need to do a combination of both, you do both. Great question there, Angela. Extremely great question. Well, Amit, all these data boxes are physical devices, except for the gateway. That's a virtual machine which you can run on any VMware server or any server in your data center. The data boxes, the gate are there. The gateway is just a virtual machine. You put it in your data center. Is the data box mounted on the hardware level? I don't know what you mean by that, Douglas. Do you mean do you screw it in to a rack somewhere? Or do you physically plug it into your Ethernet port, which is all you need to do, and plug it into power? That's really all it is. Data box is not like blob storage at all. Data box is a physical hard drive and a computer that gets shipped to you that you copy your stuff to. So it wouldn't be any different if I just shipped a server to your house and you copied all the information to the server and then you shipped the server back to me. That's what a data box is. The only difference is it's in a rubber ruggedized thing with lots of storage, which means they're going to be using RAID in the storage, most likely RAID 5, to make sure they've got high availability, high performance redundancy storage. They're just shipping a server to you. You copy your information to the server, and then you ship the server back. That's it. A gateway acts as a gateway. I don't know if I would call it a bridge. A bridge is a layer 2 device which forwards frames on all MAC addresses, except for the port that it came in on. So gateway is more like a router. It takes you from one network and moves you more to another network. Angela, that's a good question. What type of RAID is a data box? Now, Azure can choose anything they want, but let's talk about it. If they use RAID 0 and one of the hard drives fails, you got a problem. If they use RAID 5, they ship it to you, you copy your data. Worst case situation is a hard drive fails and poof, they pop in another drive and your data's there and they're all happy. So they'd have to use some flavor of RAID 5. That would be what I would use and how I would architect my data boxes. Great question, Angela. Very smart. Al, I know you and I know you well, but I don't completely understand this question. The topics that we're going to be covering from are all covering from the Azure curriculum. So there's that. Now, if you're asking what we're covering today, we're starting out with some of the data. We're going to get into compute and we're going to see how far we go, where we go from there. So let's get to computing on the Azure platform. So I know you're awake, alert, and oriented. Type hashtag Azure Architect in the chat box. And Kulte, you're asking about RAID. We covered it yesterday, so please go back and watch yesterday's bootcamp and you will learn all about RAID. So while I wait for you all to show me that you're awake by typing Azure Architect in the chat box, that's the whole point. Azure Architect, it's an Azure Solutions Architect expert training, and it's free Azure training. So let's talk about compute. What is it? It's where your computing is done, like a server or a container. And I absolutely hate these dumb terms like infrastructure as a service or platform as a service. But if you really think about it, all that compute is you're renting compute power in the Azure data center. So in your data center, you got servers, right? In the Azure data center, you got servers. No different. In your data center, you most likely have VMware ESXi, virtual machines, the VMware hypervisor. You could have the KVM, QEMU, or Xen hypervisor, but it's usually VMware ESXi. In the cloud, they make their own hypervisors, and they do the same identical thing. That's it. And it's all coming from some flavor of KVM or QEMU that's been hacked and optimized by the cloud provider. So now that you know we're talking about compute, what are we talking about? We're talking about virtual machines. That's it, just a virtual machine, the same virtual machine that you have in a data center. And when we talk about these virtual machines, they're going to have virtual CPU cores. How many cores do you want? They're going to have DRAM. How much DRAM do you need? How much storage do you need? The kind of storage, always. And what kind of network resource? Do you need a 1 gig network, a 10 gig NIC, a 100 gig NIC? Now, your virtual machines, we're going to talk about them, will host an operating system, and the software can be installed and run just like anything physical. It's just standard stuff. So we're just talking about basic virtualization. Does everybody know what I mean by virtual machine? If you don't, let me know right now in the chat box, and I might give you some special extra treatment. Hopefully you guys know what a virtual machine is. If not, we'll help you out a little bit. Let's architecturally talk about the virtual machines. And if you guys don't know and you want, I will even build one for you in my own data center. So what is a virtual machine architecturally? Let me show you. Alonzo drew me a beautiful graphic for it. And if this doesn't work, here's what we'll do. I'll build you one on a VMware ESXi server as we speak. So Here we go. If you were to buy a server from Dell right now, you would get a server. It would have CPUs, one or two of them in there. It'd have lots of error correcting RAM, may have some GPUs or graphics cards, and it's going to have some storage. That's what it's going to look like. And here's what we're realistically talking about. And apologies, I got a green screen behind me. There's a little bit of green that's coming in our graphics, and the green is actually making our graphics look a little funny. You're seeing the back of it. But let's take a server, you buy it from Dell, IBM, HP, who cares? You get this server, it gets racked, and it's supposed to be a beautiful teal that you see. But the green and the green screen don't kind of in conflict. So you got this server, you install a hypervisor on the server. And what does the hypervisor do? The hypervisor does, and what you see here is actually somebody made a type 2 hypervisor, not a type 1, which is what we're talking about. But I didn't catch it before. So you're going to have the server. The server is going to be bare metal. Then you're going to put the hypervisor here where it says host us. And then you're going to create multiple virtual machines. And each virtual machine is going to have the following: its own CPU. You're going to pull CPU, memory, and DRAM resources directly from it. Bear with me a minute. So again, you're just taking a server. Let me show you how that actually works in reality, because I want to make sure you understand it. This little graphic we had, it didn't come through. We wanted, first it was a little bit on the teal side. In addition to being on the teal side, what we got. So let's say I wanted to share this with you very quickly. Make sure there's nothing else that are sitting here, since I'm not pretty good at sharing things. Can you guys all see my desktop right now? Okay, good. So if you can see my desktop, you can see my VMware server. Now, this is just a regular server that I got from Dell. It's got two 24-core CPUs in it. My students use it all the time. And you can see that it's listed in here. It says 24 CPUs. Tells you it's got 128 gigs of RAM. And you can see right now how little of the CPU is being used, how little of the DRAM is being used, and quite frankly, how much of the storage is being used. So here's what we're going to do. We're going to take a virtual machine that's sitting here and not doing anything. I'll probably kill one, so I'm just going to create one if I have enough space. And here's what a virtual machine is. I'm going to create a virtual machine. I'm going to name it Mike's VM. And I'll give it a name. I'll tell them an operating system that I choose to use. I'll determine what kind of Linux I want to use. You can use Red Hat, Ubuntu, Windows, I don't care. I'll pick Ubuntu. Why? Because it's the most common cloud-based virtual machine on the cloud. From here, I'm going to pick storage. And then I'm going to tell it how many CPU cores I need. Maybe I need 4 cores. Maybe I need 8 gigs of RAM. Maybe I need a 100 gig hard drive. And we're going to walk you through this in Azure, how to do it. But I want you to actually see what it is, what's under the hood. And that's it. Now I've got a virtual computer. I would give it an operating system and tell it where it is, and I'm done. So as you can see, I can have multiple servers running on this single server. And that's really all it is. I'm just sharing the resources from one server. So here you got it. I take my server, I install my hypervisor, and I create machine. If that CPU system I have has 24 cores, how many systems can I make with 6 cores? 4 of them. So virtualization is just that. It's the virtual machine. So now you know, when we talk about an Azure virtual machine, exactly what it is. We took a server, installed a hypervisor, and then made little logical mini machines inside of that same server. Now you know. So when we're dealing with computing on the cloud, we're going to deal with primarily virtual machines, some containers and container instances, some app service things, and some function things. And we're going to cover them all because compute is the main thing that we do in the cloud. Cloud's a network and a data center that's been virtualized, right? So what's data center? Networking and compute stuff. So now you know exactly what we're dealing with. This is the server virtualization that we're all dealing with. So now that you're at it, And you'll see this in the free downloads if you download the Azure Lab demos, along with plenty of other walkthroughs. Well, they're not exactly downloads. What happens is you'll sign up to our platform it'll be free, and then from there you'll be able to watch the video. They're not downloads. I call it downloads, but they're not. So now let's go to the virtual machines. What are they? They're on-demand computers that sit inside of those servers. And when you pick a virtual machine, in the cloud, off the cloud, what you're picking is as follows. You're picking exactly what you need. What's that going to look like, for example? How many CPU cores do I need? Do I need 128 cores? Do I need 250 cores? How much DRAM I need? 1 gig, 10 gigs, 100 gigs, 4 terabytes, 6 terabytes of DRAM. I pick it. Does the machine need to have a GPU in it? If it does, guess what? All good to go. We'll add GPUs. If it doesn't need GPUs, guess what? I won't use GPUs. So realistically speaking, I'm picking the kind of server that I need in the identical manner in every way that I would in my data center. Because what's the cloud? It's a network and a data center that's been virtualized. So kind of keep that in the back of your mind. So we get the same virtual machines in the data center as the cloud. Now let's talk about the kinds of virtual machines. Now, if you're me, here's what you do. You determine your CPU, your memory, and then you go to Google and you say, what virtual machine has 128 cores and 4 terabytes of RAM? And after a quick Google, I may find that it's an M128S on Azure or an X1E.32XLD on AWS. Same thing. Now, Azure calls it a virtual machine. AWS calls it an EC2 instance. Google calls it a compute engine instance. Meet the new bus, same as the old bus, like the Who song. Same thing, the only name's changed. So let's talk about a general purpose compute platform on Azure. It's a good balance of CPU and memory. And these things from the general computer designed for dev and test environments, small and medium databases, low and medium traffic web server. Simple stuff, basic VMs. But what if your VM needs to be powerful? And you need this, for example. Lots of performance, lots of DRAM. Let's say you got a relatively medium-sized database or a virtual firewall, like a virtual network appliance. Or you got to do some batch processing. You've got some app servers. This is where your compute optimize comes in, and it's got a good balance of CPU and memory, more CPU cores and more memory than your basic computing. But what if you got something like a database that needs a ton of DRAM? Because you don't want to be hitting that pathetically slow block storage speed. And even the block storage with RAID, it's not good enough sometimes. So if you can load and cache that stuff in DRAM, to not hit the hard drive. You want to use swap on the hard drive. You might need a memory optimized system. So people that do big in-memory data analytics that run medium to large caches, like for example, a Redis cache, or a big database server, like a big relational database, you might need huge amounts of DRAM, and that's called the memory optimized instance. And you can find the kind of DRAM you need for your database right there. Now, how about this? What if you've got a file server kind of environment where you've got to store lots of stuff, but you don't need huge amounts of compute? No, we do that. We've done that in the data center forever. Now, Azure has a virtual machine that's optimized for this, and it's called a storage optimized system. And it's high disk throughput, high disk I/O, and it's designed for storing lots of stuff. Big data environments, SQL databases, NoSQL databases such as Apache Cassandra or MongoDB, big data warehouses, and lots of transactions. Storage optimized, lots of performance. You can do that too. Now, what if you need extreme performance? Simulations, processing, weather forecasting, weather modeling, seismic processing, fluid dynamics. You know, the cool stuff. The scientific computing that we're talking about. This kind of cool stuff, the scientific computing stuff, I love this kind of stuff. To me, it's cool. Guess what? This is called high performance compute. Why? It's the fastest, most capable in terms of performance, scalability, and efficiency. So that's all we're talking about. Want me to go over them one more time for you? Because I want to know you get it. You got it. So general purpose, relatively decent balance of CPU and memory. Think dev test, small, medium databases. Compute optimized, more CPU and memory. Think medium-sized databases, network appliances, batch processing, etc. Memory optimized, you need a lot of memory. Think relational databases, caches, memory analytics kind of thing. You need to store a lot of stuff. You go storage optimized, high I/O, high throughput. So big data, no SQL databases, SQL databases, data warehouses. And finally, scientific computing, high performance computing, weather modeling, drug simulations, DNA simulations, high performance compute. It's called high performance compute. That's what it's designed for. So now you know the basic types of compute on the Azure platform. Now, we just talked about servers and server virtualization. But what about containers? So if a virtual machine is as follows, you take a server and you virtualize that server. Now let's talk about this. Let's talk about the following. Let's talk about containers. So a container is as similar to a server virtualization, but there's a little bit different. So let's map out the container before we talk about it. In the container, here's what we have. I'm going to graphically draw it out for you. And let me go back to sharing my little fancy graphics processing. So in a container, let's say we've got a virtual machine or a server. I don't really care. I'm just going to call it a server. Because no matter what, everything resides on a server somewhere, even if it's called serverless. That's just silly marketing terms. Now on the server, host an operating system. And this is going to be critical what the operating system is. Then we typically put what's called the container engine, which effectively virtualizes the operating system. And then what we do from here is going to be as follows. We create our containers. Now here's the thing. Because we already have the operating system, we have dependencies. And then on top of the dependencies, we put our application. We're going to pop this all into the same container, and this is going to be our app. So what you can see here is on this server, we can have a tremendous number of containers. Here's the thing, which is what makes this so cool. What happens in container 1, should this container crash, should not affect container 2 or container 3 and container 4. Now, here's where this, and I didn't spell this correctly, but that's okay. Now, here's where this gets kind of cool. Because when we had a virtual machine, each one would have its operating system dependencies on the apps. And here we're leveraging the operating system from the operating system, so we don't need to install the operating system. A container is lightweight. So if we had 50 Windows servers on a main server, we'd have 50 copies of the Windows operating system. Not here. We have a single operating system, but I want you to understand this. You can only put a container on the operating system that it works with. So let's think about this. If you have a Linux system, you can't put a Windows container on that system. If you have a Mac system, you can't put a Windows container on that system. But if you've got a Windows server, you can put Windows containers on the Windows system. Want to hear something else that's kind of cool? With the new Windows subsystem for Linux, which is an Ubuntu Linux kernel on the Windows operating system, guess what? You can run Windows and Linux containers on a Windows server. Not that I use a lot of Windows servers in my life, but the point is, you can do it all on a Windows server now for those reasons. So now you kind of have an understanding of containers. So now let's talk about container instances. The Azure Container Instance is a service. It enables you to manage and orchestrate and deploy your containers on the Azure cloud. Now it's serverless, which means nothing. It means it still sits on a server, but it means you don't have to manage the server. Somebody else manages the server. Now let's think about serverless because there's advantages and disadvantages. If it's serverless, it means you don't have to think about it and it's done for you. But I also want you to think about this. If you're in complete control, can you tune up the power as needed? In serverless, you get what they give you. So serverless is good because it's flexible, but you lose control. Now, if you're hosting your containers on a virtual machine and you're in a cloud and they double your rates, you can say, bye, cloud provider, I'm going to a new cloud. When you go serverless, you're kind of stuck because they do a proprietary stuff. So serverless could be cheaper, could be easier, but you lose control, you lose flexibility, you lose agility, and there's a lot of problems that occur with that too. So serverless, non-serverless, that's up to you and the architect to determine what's most important to the business. Business agility, multi-cloud, flexibility, long-term profitability, or simplicity and elegance. And that's up to the architect with the business acumen, the executive team to make those decisions. But just understand, serverless is great and horrible at the same time. Hey, wait, a medication that I prescribe my patient is great, but it's horrible at the same time. There's side effects. So with everything, that's why the architect world is about making the right decisions. The ones right for the business. So why are we doing the container instances? It's real easy to take our code, little mini pieces of dependencies, and we can take that together, package it up, take that container, stick it on Azure, stick it on AWS, and stick it on Google and have a multi-cloud, high availability, high reliable environment at the same time. Now, container instances is like a serverless environment that's designed for package deploying and managing your applications in the cloud. It's very simple. Many of these things are automated, like task automation, job building, containerized orchestration. It can be done via Azure Kubernetes service, or guess what? You can manage your own Kubernetes service with a couple of virtual machines. Doesn't matter either. You can manage these things the same way you did in the data center on the cloud. So now you're pretty familiar with the Azure container instances. Let's talk about the Azure service. Let's assume you've got a simple website. Just a simple website. You could do the following. You could build yourself a big, secure, robust website. Some load balancers, your web servers, some load balancers, your app servers, some databases, some read replicas, some cache and queuing. And wow, you got a big, strong database. Now, big, strong web application, robust, that scales to huge millions of users. But what if you wanted something simple and elegant? What if you wanted something that's just so simple that you could just upload your code and forget about it? That's what the Azure App Service is about. Upload your website code and it's just sort of going to work for you. It's great, right? Nothing to manage. It's called Platform as a Service. Here's the thing with Platform as a Service. Can you optimize its security? Of course you can. Can you optimize its performance? Of course you can. It's like this. You go and you sign up for a service, and if it doesn't work, you have less control of it. You got to call tech support. So with Platform as a Service, realize you lose so much. But what do you gain? Simplicity and elegance. How many people like me do you need if you're running all these Platform as a Service? A whole lot less, because you just put it there and just hope it works. And that's what Azure App Service is. It's good for generic use cases, upload your code, and forget about it. Now, you think that's high performance? No. You can tune more when it's that. If you're dealing with $1 billion architecture, do they want this? Of course they don't. They want control. They want to maximize their performance, the security, and they want to tune it. But Platform as a Service is elegant. It's simple. Upload your code and it works. And this Azure App Service is optimized for web applications, REST APIs, and mobile backends. Kind of what's it look like? It looks something like this. Basically, you set up your app service. It kind of does its own thing. You connect it to a database and behind. It works great. Simple, elegant, and efficient. But you lose control anytime you get out of the infrastructure, out of a service. Now let's talk about Azure App Certificates. If you're going to deal with the web app, and you need to run SSL or HTTPS to determine who your endpoints are and make sure the messages are secure, you don't have any man-in-the-middle attacks, etc., you need a certificate. I want to have a conversation, I see Eddie Patrick's Blue Wrench, I need to know that Eddie's Eddie. Now, if I call Eddie on Zoom and I look at him and I say, hi, Eddie, how are you? I know it's Eddie. But if I can't look at Eddie and I can't hear his voice, how do I know it's really Eddie? Hence the certificate, and that's why we need this. So Azure App Service certificates on the portal, what are they? It's a private certificate that's given free of charge. Simple, easy to use. You just select your custom domain and it puts a certificate there. Very simple and elegant. What does it do? It enables a customer to create, manage, and consume encryption certificates seamlessly. Highly scalable, self-patching web code service, and it's an Azure App Service certificates in the portal, an elegant way to give certificates to your system. Now let's talk about the last thing before we're going to go to break and talk about things, and this is Azure Functions. For those of you that are AWS familiar, it's like a Lambda function. It's basically a mini serverless solution to do basic introductory things, remediate something. You take one action and react to something else. It is brilliant. Even the non-serverless fans like me love functions because object storage is open. Make a function to fix it. CPU hits 80%. Lambda function, tell somebody to do something, or Azure function. So these kind of event-driven things are unbelievable, highly useful, and one of the coolest things about the cloud. So let's talk about Azure Functions. What do? You give it some code. Quite simply, you just give it some code, and it works. So that's what we're talking about. It connects your data sources and messaging solutions. You can use it to build an HTTP-based API endpoint. You can manage IoT devices. It's pretty cool. So realistically speaking, what are we really looking at? You've got something, maybe an HTTP call. Who cares what it is? The call hits an Azure function, which does something, which then reacts to something else, which does something else. Very simple, very elegant, fantastic way to automate your systems and promote some real digital transformation. Okay, so we're going to have a lot more stuff to cover in the compute section. I've been talking for about 30 minutes. I'm going to ask you to do the following. If you haven't yet, we put a lot of time, effort, and money into developing free content to make sure that we can help everyone out there. Please share this information on LinkedIn, Facebook, Twitter, Snapchat, TikTok, email. Just tell a friend to join you in the free training. We work so hard to bring free training for the community. We want to make sure everybody gets cloud hired. Marla shared best training around 100%. Thank you so much, Marla. Ciao. So good to see you. Anybody have any questions so far on the virtual machines, containers, Azure Functions, or the app service? If so, let me know. If you've got a question, I'll answer it right now. Want to make sure we give you guys the best experience we can. Want it to feel like a classroom. Thank you, Marla. I see you over there in the chat box. Thank you, Joe H. Good stuff. I totally appreciate it. Anus, thank you so much. We work so hard. Can you give you a definition again of an Azure function? Absolutely. So let's say you want to have some little automated thing. I upload a video to a blob object storage bucket, and I want that upload to go kick off an email to somebody else. I can have an Azure function kick off a messaging service to send me an email that says, hey, Mike, your video got there. Or I could have a multi-step workload. Like let's say I've got a process. I build something, the product is ready. I can have that automatically kick off a function to send an email. Product is ready, which can then tell the packaging people to come pick it up, et cetera, et cetera. So it's mean to automate where you can write simple code. Containers borrow the OS of the operating system. Virtual machines each have their own operating system. Great question, Gopal. Virtual machines use a server to function. You can put multiple containers inside of a virtual machine, but you can't put a virtual machine in a container. A virtual machine, like I showed you, is we took a server, we added a hypervisor, we determined how many CPU cores, DRAM, disk storage we need, and then from that, we would do, we launched the virtual machine, installed the operating system, application dependencies, etc. So there's the things we need to do. New to this, you're trying to absorb as much as you can. Zombie, come back again, and come back again. You're new to this, welcome to our world. Congratulations, it's a lovely world, and we love it here. So join us, absorb, watch it twice, thrice, 4 times, I don't care, and keep coming back. Bring a friend too. You'll do fantastic. Are containers also servers? No. A server is a physical device. You know, the kind you call the computer store, and it's got multiple CPUs, multiple power supplies, error correcting RAM, special hard drives, RAID arrays. So that's a server. Then, to create a virtual machine, you slap a hypervisor on that, like I showed you with my server, and there we can partition the memory and CPU resources to multiple things. Now, a container is a subset of a virtual machine. So you can have a virtual machine that's got 1,000 containers on it. You can have 10 virtual machines in a server, and you've got 1 physical server. How would you troubleshoot a container, Cruz? You're asking me how you would troubleshoot a car accident. Meaning, was the car driving too fast? Was the car reckless? Was the ground slippery? Did the brakes fail? There's about 1,000,001 things that can go on in the container. Is the container wrong? Is the container orchestration wrong? Is the code wrong? So if we really wanted to talk about troubleshooting containers, we could spend about a month full time on it, because we'd have to talk about all that goes into a container. So if you're really looking for how to troubleshoot a container, I would spend a lot of time with the Kubernetes, reading Kubernetes and Docker materials, and I would also learn application development. But if your goal is to be a cloud architect, you're not going to be troubleshooting containers anyway. You're going to be designing a system, inclusive of containers, etc. So it depends first on the job you would want. I am not an operations guy, so I don't do troubleshooting. I'm an architect. So it really depends on the career you want. But we could do a 1-month troubleshooting course, but that would have to get pretty expensive, because we'd have to bring in we'd have to teach you, first how to code, because you can't troubleshoot something that you don't understand. And then assuming you were a good software developer to learn how to troubleshoot, that would be part of it. And then we'd have to get heavy into the containers and the container orchestration. We'd also have to teach you networking, because there could be networking problems. There could be operating system problems. So that's not like the kind of answer I could give you in just a week. Gopal, if a server with a Unix aux, but the container is a kind of container, no. So if you've got a Unix server, you can put Unix containers on it. If you've got a Linux server, you can put Linux containers on it. If you've got a Mac OS system, which is BSD Unix, that's all you're going to put on it. No, the containers must match the operating system. Now, I did tell that with Windows servers, you can put both Windows and Linux containers. Now, 3 years ago, that wasn't true. With the Windows server, you could only do a Windows container. But Windows now allows a Linux kernel to be installed on Linux called the Windows subsystem for Linux. And that's why a Windows operating system can host a Windows or a Linux kernel, because it has both as part of its now operating system. Good question. A container engine is used for containers, and a hypervisor is used for virtual machines. Completely opposite technology. Kishan? Well, no certification is going to get you the job. So the question is, what skills do you want to learn? If you want to be a cloud architect, it's all about knowledge of the network and the data center, sales, executive presence, communication skills, leadership skills, emotional intelligence, sales, presentations, ROI modeling, and designing of BGP, OSPF, virtual machines, containers, container orchestration, load balancers, DNS, business applications, etc. That's what an architect does. And that's the kind of knowledge an architect has. Now, certification doesn't get anybody an architect or engineering job, but certifications help you get an interview. So there's that. Now, a cloud engineer is the complete opposite of an architect or a system builder, which means they still need to know BGP, OSPF, switching, VLANs, VLAN tagging, VLAN trunking, IP addressing, subnetting, or supernetting, just like the cloud architect. But now they have to do it, so they have to know how to configure it. Now the engineer still needs to know containers and container orchestration and server virtualization and databases, etc. But they're now hands-on. Architects design, present, and sell. Engineers hands-on. So the engineer will also need to know Python, as well as Linux, as well as Terraform. So Kishan, you're asking me certifications, and I'm talking careers. They're not the same. But certifications help you pass and help you get an interview, which is great. Let's get back to the content. And while we're at it, give me a hashtag, Azure Solutions Architect. Because we're doing Azure Solution Architect Expert Training, free Azure training, and it's part of our AZ 305 free Azure course. Okay, so let's get back into the fun. Let's get into the fun. And maybe, just maybe, let me walk you through before we do it, a little bit of containers and a little bit of virtual machines, because I'm a little worried that not everybody completely understood it, and I want you to understand it. So let's walk through this one more time. Let's look at it this way. I want you to understand the difference. So here we've got a server. This is our physical server. Now what we're going to do is we're going to put a hypervisor on it. This is a hypervisor. After we do the hypervisor, what are we going to do? We're going to create our virtual machines. And what's in the virtual machine? Let's make sure we turn off the fill in this virtual machine. Format shape. No fill. So now in this virtual machine, what are we going to have? It's going to look as follows. We're going to have an operating system. And we're going to have the dependencies. Then we're going to have the app. I built the virtual machine with you, but that's okay. So this is what we're going to have in a virtual server. Now, does anybody see the slowness or problem with these virtual machines? How much memory and overhead do we think that these operating systems take for each virtual machine? A whole heck of a lot of it. So now let me show you what the container is. And the containers can be deployed on a server, but they're usually deployed on a virtual machine. So let me show you what the container is going to look like in reality when you get there. If you build it, like you would in the cloud, you're going to have the physical server, which is going to have its hypervisor, which is unaware of you. And then what you're going to do is here's how this works. And I want you to understand the lightness of the container versus the heaviness of the virtual machine. So now in this particular case, we're going to turn this into a virtual. So basically we've got a hypervisor, and now what we're really going to have is this virtual machine. It's not going to be a physical server, it's going to be a virtual machine. Now we've got our virtual machine. Now we have over here, we've got to have a container engine. And the container engine is then going to have containers. And each container is going to look like this. Move this over. Now the containers won't have the operating system, so they're going to weigh less. And that didn't work. Let's shrink this. And this is realistically speaking now what we have. We have this, and we're going to have a couple of these. What you can see is, to try and make this more clear, this is the server that has the virtual machine. All of this stuff is actually sitting in one of these things. Can you see the difference? So what you're dealing with here is on the server, the hypervisor in each virtual machine. Here, this is a virtual machine that's housing all the containers. So I hope that means something to you. So let's talk about Azure Images. I'm sure many of you have installed an operating system in the past. You take your computer, you put a Windows disk in, or an Ubuntu disk in, or a Red Hat disk in. You tell the BIOS to boot off of your CD or your USB drive. Boot. It boots up. Ding, 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 ding. And then you install it, right? And when your Windows computer gets corrupted, every 90 days you erase the operating system and reinstall it to make it work good, right? Okay. So make it very clear. You install it. Now, what if instead you could just make a copy of your server? A perfect, identical copy. And then every time your Windows system was bad, you could push a button and it would erase it and reinstall it to perfection, fresh out of the box new. That's what an image is. And images are 20 years old. We've been imaging our servers for decades. So instead of having to reinstall the operating system and the dependencies and patch this, and do, it's all done for us in an image. And if any of you guys have worked in the data center with VMware ESXi, you make a server, you got an ISO file, a copy of it, you copy that server. You want to move the server, you copy that file to another computer. Want to move the server to a bigger server, you drag it. And this is why we've been dealing with hyper-converged cloud-based data centers for 20 years now. For that reason, the imaging of the servers. So what is an image? An image is a bit-by-bit identical copy of your server. And you can use that to launch new servers. Now let's think about this. You can take your server, you build it, you optimize, and you make a copy of it called an Azure image. Wait, I want a robust firewall in the cloud. I can go to the AWS Marketplace, the Azure Marketplace, the Google Marketplace, and say, I need security. And I can buy a Cisco or a Palo Alto or a Fortinet firewall, virtual firewall, all of this stuff, all this cool stuff is going to sit in a virtual machine. Where's that going to come from? An Azure image. So you can make an image and store it as a copy of your server. And one image can be used to literally support 20 deployments. So it's speed, efficiency, and great protection. So what Azure images do, you make your code, you make your baseline virtual machine. Here's my golden image, hardened, locked down. You use this as the starting point for all other servers. That's what it's typically used for. But let's also think about it. I have copies of my VMware servers, all in images. I want to go to AWS, drag them over, I'm done. I'm going to go to Azure, drag them over, I'm done. No big deal. So let's talk about images and when you would use them. I'm stuck in my data center, but I want to make an Azure image of every virtual machine I have and keep it in Azure along with my data. My 3 data centers go down. There's an earthquake. There's a power failure that affects all the power companies. There's an electromagnetic pulse and all my data centers, my 3 data centers are dead. I've got images of my virtual machines and my data in the cloud. Launch the images. 8 hours later, I've got a full production ready system in the cloud. Perfect disaster recovery. So hope you understand the images at this point. Migrations to a new cloud. Perfect. That's why customers do lift and shift. What's lift and shift? Take my VMs in the data center, pick them up, move them to VMs in the cloud. Bob's your uncle. Everything's smooth and simple. Quick moves, fast moves, and you can do it multi-cloud. Now let's talk about when servers come up. I don't know when the last time you all installed like Linux, like an Ubuntu Linux, or let's say a Red Hat Linux system, or a Windows system. And when you first install one of your Linux systems, say Ubuntu, it comes up and then all of a sudden you say, I have to do the sudo apt-get update and the sudo apt-get upgrade to basically optimize and patch it and fully bring you to the newest version of the system. You do that as soon as you build a new system. Hey, wait, you install Windows 11. Guess what? It's got 1,000,001 security vulnerabilities in it that have been identified. I'm exaggerating the concept, but here's the point. So you got all these security vulnerabilities. What do? You patch them before you think about using the server. So we have the opportunity on the cloud where we can get our systems come up dynamically, which is why we're on the cloud, auto-scaling and other cool stuff. So our systems can come up automatically. But what if we want them to come up and patch themselves? Or install in a web server function. That's called Bootstrap automation. What is Bootstrap automation? I will tell you right now. Bootstrap automation is as follows. You take a system as it comes up. And when it comes up, you give it commands. Update the operating system, install the Apache web server, etc. That's called Bootstrap automation. You can do it on all the clouds. It's basically a service to automated template to configure things on demand. Makes it very easy, especially if you start with a virtual machine from scratch, a standard image, get it up and running as needed with all your features, functions, etc. So very cool stuff. We absolutely love it. Now let's talk about your options for virtual machines. They're different on the cloud than the data center. Here's the way it works in the data center. I buy a server and I make my systems. And I own them. I'm going to tell you right now, it's much cheaper for you to go to Dell and say, I need a 64-core server with a terabyte of RAM than it is to go to the cloud and get a 64-core server with a terabyte of RAM. It has to be. Here's why. For the cloud to buy a 64-core server, they have to buy the same server you do. And then they have to rent it to you and make money on it. So it's always going to be cheaper to buy the tech yourself. Now, is it cheaper to have your own data center and design and buy and operate all your tech versus as the cloud? No, that's another story. But it's always cheaper for you to buy the tech than just to rent the tech. Just like for you guys that rent houses. The landlord has to make money, everybody. If it costs him $2,000 to hold the mortgage, he has to charge you $2,500 or $3,000 in rent. Same thing, the cloud provider is doing the same. But what's good about the cloud is you can pay for what you need. Versus in the data center where you must pay for max all the time. And I want you to think about this as we go through. Let's take a retailer, somebody that's big retail. What's the retailer's biggest day of the year? Typically speaking, in most countries, the Friday, at least in the US, the Friday after Thanksgiving, owing into the week of Christmas. So if you're a big retailer, and you're an e-commerce provider, what do? Do you build your systems to survive the Christmas holiday when your sales are coming in? What are your sales like the rest of the time? Maybe 10% of that. So in a normal environment, you buy the stuff and it sits idle all year long, 1%, 2%, 3%. You're paying for capacity and you're not using any of it. And then Christmas comes and your demand peaks and you maximize your stuff. And that's why you bought those servers, because you paid all year long for your peaks. You pay for peaks. Let's talk about the cloud and why we like the cloud. On the cloud, I can buy for that 3% all the time. And then I can add the Christmas capacity when I need it, not the rest of the time. So granted, it's a lot cheaper for me to buy the same hardware in the data center than it is to rent somebody else's. But what if I need 1,000 cores during Christmas and only 100 cores the rest of the year in terms of compute power? Well, it's cheaper for me to pay too much for those 100 cores the whole year and get the 1,000 cores when I need it than to pay for 1,000 cores the whole year. That's why we're going to the cloud. So with the cloud, we typically have 3 pricing models. Pay as you go, which is on demand, reserved, and spot. And they're all critical to understand. And proper cost control is a combination of all 3. So let's talk about it. Let's talk about the pay-as-you-go pricing strategy. This is billed per second. There are zero long-term commitments. There are zero upfront payments, and you have the flexibility to scale up or down as needed. So let's talk about when and why and where. So imagine this. Let's say, for example, I was going to do a hosting platform like this. Let's say I was running and it was not on YouTube. Normally speaking, my YouTube channel gets about 100,000 views a month. I do a boot camp, we might get 30,000 views this week. So if I had to host the servers, I would buy extra capacity for these things. I would. So I would use this pay-as-you-go, on-demand kind of thing. Let's talk about another situation. We're going to start a new business that sells cat toys. Because Chris has a cat, I have a cat, Nablaga has a cat, and we love our cats. So we want to start a business doing cat toys. Do I know how much traffic I'm going to get at the website? I've got no idea. It's a new business selling cat toys. Now, if all of a sudden there's like Taylor Swift talking about the cat toy and Katy Perry talking about the cat toy and Jennifer Lopez talking about the cat toy, Madonna talking about my cat toy, and it's on Fox News, CNN, MSNBC, ABC, NBC, and CBS, all of a sudden the world's going to want to buy my cat toys. So if I had my own data center, I'd be in trouble because chances are I didn't plan on the world's biggest celebrities and media stations talking about Mike's cat toys. It'd be a problem. So this is where the cloud's good. You go to the cloud, you don't know what your demand is, you don't know what your business growth is going to be, and you buy on demand. Wonderful. Now, after a year or two running my business, I know what my capacity is. And I don't want to run on demand. I want to basically reserve it and get a discount for knowing what I'm using. But if I don't know what I need, if it's a new business, if it's an unknown workload pattern, if it's a short-term road, I want to use on demand. Imagine this. I got a website. It's running naturally on 5 beautiful web servers, running smooth. Running on 5 app servers, running on a database. It's good, good, good. I've reserved, and we'll talk about that next, my 5 web servers, my 5 app servers, and my 5 data center servers because they run all the time. All the time. And now I was in about 25 to 30 articles in the last 2 months or 3 months of people writing about Go Cloud careers and getting people cloud hired. We released another article today about a program we're doing for the military to help our veterans get cloud hired. When that kind of stuff tracks, if I only had 5 web servers, it's not enough. I might need 6 web servers, 7 web servers, 8 servers. And this is where I can use the on-demand, add capacity on demand. I paid for my 5, I've committed for my 5 web servers, but I need 10, and all of a sudden auto-scaling gets me to 6, 7, 8, 9, 10. Unknown workloads. That's why we're doing on-demand. Let me tell you this. If it wasn't for on-demand, I don't think anybody would ever go to cloud computing. This ability to scale on demand, the agility it provides, the flexibility is so powerful. That's the whole reason in my mind behind cloud computing, purely auto-scaling. Now you know why the on-demand. Now let's say I'm an established business like Microsoft. I always have 50,000 web servers, 50,000 app servers, and that's my standard thing. In that situation, I'm not going to use on demand for my 50,000. I'm going to commit to or reserve 50,000 servers. And here's why. If I can guarantee to the cloud provider, I need those 50,000 servers or those 3 servers, who cares, whatever the number is. For 3 years straight, I can get a discount of up to 72% off of the premium pricing. And here's why. If I do this, Microsoft, I need the server. Microsoft says, I've got a commitment from you. I'm going to go buy my servers. So it gives Microsoft the ability to invest in its infrastructure because of a guarantee from me. I guaranteed payment, and because I'm guaranteeing use, they're going to give me a huge discount. Now, here's the good news. You can reserve a virtual machine, realize you reserved the wrong kind, and change it to reserve a different kind. And if you reserve something for a period of time and you need to cancel, you can, but you're going to pay a fee, and it's going to be pretty heavy. So reserved instances, Guaranteed use, know what you're going to use. Expected workloads, fixed corporate budget, and consistent use of your system. Optimal. So what are you going to do? Reserve what you know you're going to use and use on demand what you need when you don't know. Now, the last one always makes me scared. Spot pricing, spot instances, preemptible instances, depending on what you call them. Azure calls it spot pricing. AWS calls it spot instances. I think I can call it spot instances if I remember correctly. Google calls it preemptible instances. This stuff is scary stuff, and it's also cheap stuff. If you need lots of compute capacity, you can get spot pricing. What is a spot price, spot instance, preemptible instance, whatever you want to call it? It's an instance that's extra capacity. So let's say Azure's got an extra 100,000 servers. You basically bid in an auction. I'm willing to pay 3 pennies per hour per system. And if your bid is accepted and it's unused capacity that's sitting there wasted, AWS or Azure or Google will rent it to you. Sounds great, right? Well, it is, but there's a catch. Here you bid 3 cents. You're using the computers, and out of nowhere, Cookie Monster comes in and bids 4 cents, and he needs all the servers. You are completely shut down, but Cookie Monster comes in and all your gets access to those systems all get to him. And then when Cookie Monster is running his workload and Big Bird shows up, Big Bird and Snuffleupagus reserve it for 6 cents. Cookie Monster systems are shut down. So what's good about spot pricing is you can bid on unused capacity, but it's unused capacity. If anybody else bids you, you get shut down. So this is stateless stuff. So what I view spot pricing is, if you need compute capacity on non-critical workloads, fault-tolerant workloads that can restart as needed, or stateless applications. Do not plan your business around something that can get shut down on you. Keep that in the back of your mind. So we're going to get into some, actually, let's do a little more on this section. I did like the Cookie Monster when I was younger. I loved Sesame Street. So let's talk about securing virtual machines. Now we'll talk about real security. And what is real security? It's firewalls and IDS IPS systems and subnet blocking and securing your virtual machines, etc., with network security groups. So, at the minimum level, with every virtual machine, you have the opportunity to add a network security group. It kind of like keeps traffic out of it. And you can filter what ports you're allowing in, just like a firewall, that kind of thing. Keep that in the back of your mind. And lastly, if you want your virtual machines to connect to the network, you got to have a network interface card, just like you do in your regular system. And your virtual machines can have a single NIC connecting to one network, multiple NICs to be multi-home to multiple websites, multiple servers. If you put a public IP address in the network interface card, it's going to connect to the internet. If you give it a default route, private IP address, it's used internally. So I babbled a lot. I hope you guys had some fun with the babbling. We covered a lot. And we're going to get to one of the coolest topics, databases, coming real soon. But before we do, let's take in about 10 minutes of questions. If you got some questions, please ask me right now. By the way, if you haven't subscribed, please subscribe and hit the bell. We do so much free stuff, and we want you to be available and see it. So please subscribe, hit the bell, hit the like button. And then let's bring in a couple of the questions. And make sure you sign up for the free subnetting and networking workshop. You don't want to miss that. Hey, Mike, are you required to pay for all the reserved usages up front? You do have to pay for them. I don't remember if you can pay them up front or on demand. I'd have to check that. But it's a great question. I've never really had to pay for any of these systems. We run our own OpenStack cloud here. We've got 10 servers with 24 cores. We found that it was about 30 times cheaper to build and run our own cloud than to use somebody else's cloud. So I don't pay cloud bills. But I do use a cloud, ours, our own private cloud. Please feel free to keep your questions coming, as Eddie said. I mean, it could be that you got it all and we're doing good and I'll just go to the next concept. And that's the case, I'm happy to do it. Great question, Angela. If you reserve a virtual machine, you can definitely use it to a different type. So yes, you can. Douglas, thank you so much. Tracy, I was so grateful for your nice comment. I'm so happy you're learning a lot. Like Alonzo says, you have questions, we're here to answer them. Kind of like there used to be a Radio Shack question. You have questions, we have answers. We want to help you build your career, so please feel free to ask some questions in the next 5 minutes. Cloud hired Leonardo, you're learning so much. Fantastic. What's the difference between platform as a service and software as a service? Look, these are getting into really trivial concepts, and we do have something we can show you. Here's the thing. Infrastructure as a service is what I use, which basically means you have full control. Platform as a service gives you a place to put your stuff that's pre-made where they manage it for you. Here's the thing with platform as a service. You have no control, none. So you're not dealing with managing your operating systems. You're not managing your security. It's all done for you. So infrastructure as a service, make it as good as you need it to do. Platform as a service, it's managed by somebody else for you. Consider it good cookie cutter average person solutions. Software as a service, it's like Microsoft Office 365. It's all done for you, all ran for you. So technical differences, how much control you want. As you get closer and further on that continuum, platform as a service, software as a service, you lose flexibility, customization, and all control. But it gets cheaper. So the question is what you're in for. If you're looking for digital transformation, it's probably infrastructure as a service because you can do the most. You don't have to put a network security group on your virtual machine, but if you don't, it's going to be hacked. So it's up to you. I would lock down and not allow stuff into my servers that I don't want it to be. Failure to do so will result in you getting hacked, but there's no requirement that you have to do so. Spot prices. Okay, yeah. So here's a stateless application. If it starts and stops, nobody cares. That's a stateless application. So I want you to think of a spot computer as like a spot car. You drive it and it just might stop and leave you on the side of the road. So if you basically have no time limits, for example, and you want to do a spot car pricing, you get in your car, you're in Florida. You try to drive to New York. You go 30 miles, your car shuts down on you. And then the next day it boots up and you go 300 miles. And then your car shuts down on you. And then your car doesn't work for 3 days. And then it works and it takes you to New Jersey, then your car fails on you. And then it can take you to New York the next day. That's spot pricing. So for a stateless app that doesn't matter like that, where you can just go from one to the other, now you're getting stateless applications. That's what spot pricing for. Now by comparison, pretend you're an ambulance and you've got a patient that has to go to the hospital. Can you afford for that ambulance to be shut down? No, people will die. So spot prices are only good for that kind of stuff where it's stateless and it doesn't matter. Only when it really doesn't matter. Good question, y'all. Extremely good question. Love that background. Joe, as a cloud architect, do you find yourself recommending on-site versus provider? I recommend anything that makes my business better. I had a client that I did 2 months of consulting and an ice machine saved them millions of dollars a year. And that's what I recommended. I recommend stuff that needs extremely critical low latency and performance be done in the data center. I recommend offloading things to the cloud that the cloud does better, faster, and cheaper. For me, Joe, I'm an architect. I am not married to any technology. I am married to make my customers more profitable. I'm an architect. I'm a digital transformation specialist. So I design, present, and sell. I never touch the tech. And as an architect, I have to figure out what makes my cousin's business better, what increases their top line revenue, what decreases their expenses, what decreases their error defect rate, what improves the collaboration or communication. And whatever that thing is, if it's a new suit, if it's an ice maker, a workflow, a book, a training piece, I don't care what it is, that is what I recommend. So it all depends on it. What is the best method we would suggest for a large-scale engineering? So I want you to understand the difference between engineering and architecture. There is no best anything. There is best for the business. So what really has to determine what is, because I'm an architect, I'm not an engineer. An engineer, you ask them what's the best firewall, they're going to tell you on features and functions. I am not an engineer, I'm an architect. So what's the best method to suggest? What is the business's business problem? Business problem. That determines everything. If they lose $1 billion a minute, I can't do auto scaling at all because it's too slow. If they have a high dollar volume per minute, I may need to pre-warn my load balancers and tell the load balancers to scale up ahead to make the virtual machine scale ahead of time. If we're dealing with small amounts of money where the cost of technology is greater than the cost of the sales, I'm going to scale slow with auto scaling. So I have to determine what's the business problem. There's no problem that's ever solved without knowing the business problem. I'm going to ask you all right now this question. This will tell me whether you think like an architect or think like an engineer in 10 seconds or not. Both are appropriate. I have a house in Alaska. It's 2 o'clock in the morning, and I want the answer in the chat box. The house is in Alaska. It's 2 o'clock in the morning. There's nobody that can arrive via plane, train, or automobile for 24 hours. It's 0 degrees outside, and guess what? The heater just broke. Now, I want all of you in the chat box. What is the problem? Just give me an answer in the chat box. Tell me what you think the problem is. And I want to show you the mindset of the architect versus the engineer. Because by asking that question, I need you to know that the architect solves the problem. Solves the problem. And it identifies the right problem. The correct problem. The correct problem. I'm seeing some people that know what the right problem is. I'm seeing people that have no idea what the problem is. A few people have figured it out, and most still haven't. Here's the problem. It's cold outside and somebody might die. It's not a problem that the heater's broken at all. The problem is it's 0 degrees and someone will die. And there's no help they can get since there before someone will die. So if you identify the problem is that people will die, you're going to start looking for firewood, anything you can do to keep the people alive. If the problem for you is the heater, you're going to try and fix the heater. Second, there is no best technology ever. And one of my architects just went on an interview, and they asked him, which is the best firewall? And it was a trick question. The question was, what was the best firewall? And he said, I'm sorry, I can't answer that until you tell me what's the application. What are you trying to protect? What's the workload like, the traffic flow like? And they said, you're hired. And they said, we didn't want somebody that could make a jump and just give me the answer. We're not looking for a knee-jerk reaction. We want someone to think about it, to figure out what the problem is, because every problem demands a different solution. So I wasn't trying to be challenging with it. I can't answer your question until you give me the business impact, what it takes in terms of downtime, how many seconds it takes for auto scaling in this cube, how many seconds can the business tolerate, what's the dollar volume that's coming in, the traffic patterns, etc. That determines everything. Everything else is merely just silly tech. Containers can also be used in stateless-based applications, absolutely. Well, you can have multiple network interface cards for multiple VMs. That's why we had multiple. Even though the virtual are the same underlying tech across providers, are there material misservices? No, not at all. The names have changed. So X1E.32XLG is AWS, and M128S is from Azure. You can auto-smell small VMs, large VMs, or anywhere in between. And then we'll answer Crux's answer because that's the most dangerous one I've ever seen. Crux, you can do any job you want. Yesterday we had Daniel Bosu. He was working at Nordstrom in the retail department. He just got his first cloud architect job. We've had Romanik Ivan Tamba. His last job was serving food, and he's now a solution architect with AWS. We had on Jordan Kitko, who's a solution architect with AWS that had no job before. We had Jeffrey West, who was doing geospatial imaging. What career do you want is the one that you do next. It has nothing to do with where you come from. It doesn't matter what you ate for dinner last night. It has no effect on what you eat for breakfast, lunch, and dinner today. What do you choose to do? What do you choose to learn? What do you choose to be? That affects your tomorrow. The question you should ask yourself is, if you enjoy designing, presenting, and selling, you'll like being an architect. If you like coding and configuring, you'll like being an engineer. So it's what do you choose to do with your life, not what your background is. I can do one more, maybe two. How do one which marketplace load balancers are best for applications? Marla, and Marla's a rock star. This is all about getting the requirements. Now, if you need certain extreme feature sets in your load balancers, we're not typically going to get that out of like an Elastic load balancer on AWS or an Azure load balancer. We need to go to the marketplace and get something from like an F5. But for the most part, if we're dealing with normal application or network load balancer functions, the cloud providers' load balancers are pretty rock solid. But when we start getting involved in stacking load balancers and weird load balancer algorithms and routing traffic, that's when we got to go to things like F5 because they're more capable. And Marla, what I'd say, this is one of those things where, can it be done on the standard stuff? If the answer is yes, good. And if not, F5 all the way. That's their business. They've been doing these things for decades. Okay, so we're going to get back to the Azure Solution Architect Expert Training, the free Azure Training, the AZ305 free course. Please give me a hashtag Azure in the chat box. And then once I see a bunch of Azures and hopefully Cloud Hires, we'll get started again. And while you're at it, hit the like button, comment, share, subscribe, please. Tell a friend to join us. After class, make a social media post. Tell everybody that you were at this free training today. And invite others to watch and learn some of the great things that you learned. Talk about what you learned. Invite others. Like I said, it costs as much as a car to produce these free courses. And we want as many people as possible in the world to be helped. And I'm starting to see some of the stuff in the windows. I'm seeing some Azure stuff. It's making me happy. Let me fill up my water bottle because it takes a little more energy to deliver these presentations than you could possibly imagine. And it shows the 6 people on my team that are here helping and the many people that are not part of my team that are even helping them out. Shows them that you're all having fun.
To clarify what you mean by sick people on your team, you mean the physically sick people.
Oh, I thought I said 6 people. I didn't say 6.
Oh, it sounded like sick.
Oh no, 6 people. Lawrence, or anybody that wants to buy the live component, all you have to do is reach out to my team. We can upgrade you easily with the cost difference. There's no reason for it to be complicated. It's very easy to do. People upgrade all the time. Okay, I'm starting to see the Cloud Hires. I'm looking happy. The Azures. Yeah, I do drink a lot of water. What most people also don't understand is I spend 3 hours in a room, 90 minutes in a 120-degree room doing Ashtanga yoga each day, and then another hour or so in a 160-degree room just to be able to walk. So yeah, I'm constantly drinking water. Okay, so let's talk about databases, everybody. All kinds of cool stuff. So what is a database? A database is an organized collection of structured information, typically stored in a computer system. A database is usually controlled by something called the database management system, which is kind of cool. And together, the data and the database management system and all of the applications which are associated with that are often considered to be called a database. I'm a simple person. I like to call everything a database. I don't make up funny names. I don't use any kind of cool stuff. I just call simple stuff. So let's talk about a database. It enables us as a rule to take structured data and keep it and store it in an organized fashion. A manner that enables us to get it when we want and store it when we need it. A database is comprised, like we said, of the data, database management system, and the applications. Now, typically, when we're dealing with relational databases, we're going to store our data in a very structured way, like rows and columns. Kind of think like an Excel spreadsheet. Now, when we're dealing with our data and relational databases show us data that's related to each other. I want you to hear this again. Relational database shows us data that's related to each other. If I change the price, will it increase sales? Do users from Miami buy during a hurricane? Is there something that I can do in this location to improve this? Related data. It's hot outside, ice cream purchases go up. So when the weather's getting hot, maybe increase my ad budget. I don't know. The point of all this data collection, data aggregation, data anything, is to make better business decisions. That's why we're doing it, to make better business decisions. So let's talk about how we do that. Typically speaking, when we're dealing with databases, the data is structured. So look at it this way. It's showing the relationship between the variables. Order 1 was this much from this customer, etc., etc. Is there something that I can make a relationship to make a better business decision? Now, when we're dealing with databases on Azure, we have the usual suspects, and then we can still put a database on a server, just like we would do in any other data center server, but that's us and our own infrastructure as a service. But if we don't want to install our own, which we can totally do, we can run one of the pre-made Azure databases. And which ones do we have? We have SQL databases, database for MySQL, database for Postgres, database for MariaDB. And in most cases, with Azure, their scale and the maintenance is kind of serverless and it's automatically performed by Azure. So they're fully managed. They're also serverless. And Azure will say that their databases are 99.995% available, and they're encrypted with an AES 256-bit encryption key. So let's talk about the database for MySQL. Well, it's a fully managed version of MySQL Community Edition. That's it. Standard MySQL database, but they deal with all the storage, etc. It does automatic backups via an image, and it does point-in-time restoration for upwards of 30 days. We get automated patching, and again, it's pay-as-you-use pricing. It uses basically a FIPS 140-2 or an AES 256-bit cipher. Now that's MySQL, owned and managed by Oracle these days. Great little mini database, widely used on the internet. But what if you need something a little more big and scalable? Well, you can use PostgreSQL as well. High availability system, again, similar automatic point-in-time restoration, scales as needed, automated patching, and again, pay-as-you-go pricing because these are serverless environments. How about MariaDB? Another great relational database. Open source, high availability, pay-as-you-go pricing. Now this one gives you about enterprise-grade security, which we love. We love it, gives you monitoring and alerting. And of course, you can do the same automated backups, and it's based on MySQL Community Edition. Let's talk about the serverless compute for Singer databases. We've got Azure SQL Databases Serverless and Serverless SQL Pool. Now, when you start dealing with this stuff that's proprietary, you run into a challenge. Proprietary stuff's hard to move. MySQL, you can use in multiple clouds. So let's talk about Azure SQL Database Serverless. What is it? It's a computing tier for single databases. It's auto-scaling. It builds per second. And it basically associates your compute with some kind of auto-scaling pause delay. You can configure it. It's great for intermittent, unpredictable usage patterns because it's going to grow as you need. What is it? It's a distributed serverless. Let's talk about serverless SQL Pool with Azure Synapse Analytics. What is it? Azure Synapse Analytics. It is a distributed database processing system. We're dealing with serverless SQL endpoints used to query the data in an Azure data lake. Basically, it's serverless SQL Pool Azure Synaptics is really about optimizing the big data environment, big queries, et cetera, et cetera, et cetera. So now you're pretty familiar with that. Now let's talk about NoSQL databases. We just talked about relational databases. NoSQL databases are different. They are not arranged necessarily like columns and rows. They're typically key value pairs. They can be document type databases, graph type databases, or wide column databases. Here is the thing. I love that solar powered mic. Thank you so much, hand to God. It's a mental toughness thing, let's just say, from some special training that I have that keeps me going. Neither here nor there, you may actually be familiar with some of the training. So there is that. So let's talk about NoSQL databases. We use them. They typically have a flexible schema, and they scale, which we love. So we use NoSQL databases when we need schema flexibility, when we've got unlimited scalability, because this stuff can really scale. Can work with less structured data. Typically with NoSQL database, we've got a document type, which stores data in a similar format to JSON. We've got a key value pair, which is typically what we're using, where each item contains a key and a value. We've got wide column databases, which stores data in rows and columns and dynamic options. And of course, we've got graph databases in this NoSQL family that store data and nodes and edges, etc., and shows the relationship between them. Here's the thing. You're typically dealing with the following. You've got a key identifier and a value that you're trying to store. So that's really the key with these NoSQL databases. They're key value databases. Now here's where we get into the danger zone. As a cloud architect, we're going to talk about the Azure Cosmos DB. It's the equivalent of Google Cloud Bigtable. It's the equivalent of AWS DynamoDB. This is a proprietary database, folks. Proprietary database, which means if you use this, it's going to make multi-cloud impossible for you or challenging. I have no use for this perfectly excellent database. I can't use DynamoDB, and I can't use Google Cloud Bigtable for the same reason. I like open standards. So if you need to be multi-cloud, Apache Cassandra, if you've got a lot of write traffic. If you've got more read traffic, you can use MongoDB. Again, there's lots of great NoSQL databases. Choose the one as needed. We're going to talk about next, Azure Cosmos. It is a wonderful, fully proprietary database, which is proprietary to Azure, which means not multi-cloud. So we don't recommend it, even though it's a great database. It's fully managed. It gives you single-digit millisecond response times, which is relatively good. It's immediately scalable. It gives you great security and multi-region rights to any region. Now remember, proprietary. So they say 99.99% available. That's good, not great, because that means 52 minutes of downtime per year. You can make it more highly available by using multiple availability zones by default. It's serverless, and it stores the information on high-speed SSD storage to reduce latency. What is it? It's a globally distributed database, just like DynamoDB, Google Cloud Bigtable. Low latency read and write, highly scalable, available in all regions, multimodal, schema agnostic. So it's a fantastic proprietary NoSQL database. It's proprietary. Where would you use this? Same places you use Google Cloud Bigtable or DynamoDB, e-commerce platforms, retail industries, event sourcing, gaming leaderboards, ridiculous amounts of financial transactions, that kind of thing, web and mobile applications, storing game player state. So there's lots of use cases for this kind of stuff. And now you know the SQL databases. Now let's talk about scaling databases. I want you to think about it this way. For example, about 10 times a day, somebody says, Mike, is my background good enough to be a cloud architect? And I like to say, I just got people hired with 0 background and 0 degrees as a cloud architect. It doesn't matter what your background is. But I get asked that question at least 10 years. Somebody wants to tell me their past. And I always tell people, it's not your past that I'm concerned about. It's your future that I'm concerned about. But every day, at least 10 people says, Mike, I've done this for 20 years. Am I good enough to do this? And I say, do you want to do this? And they say, yes. And I say, you're good enough. And they say, but Mike, what about my background? I say, I've got a waiter hired. I've gotten food servers hired. I've gotten retail workers hired. The fact that you've been working in tech for 20 years, of course I'll get you hired. So there's that. But everybody wants to do this. So now, yesterday, our team got over 80 requests. Is my background good enough? So here's what caching does. If I had to answer all 80 requests, what would happen is I'd go bonkers. I just couldn't respond to them. So what caching would be is in front of me, you put somebody else. And this person remembers every response I get. So when the person says, Mike, is my background good enough? The person automatically says exactly what I told them and exactly the words. The next person comes, gets told the same thing. The next person asks the same questions, the cache responds. The next person asks the same question, the cache responds. The next person asks the same question, the cache responds. Then somebody else says, Mike, I'm a nurse. Could I become a cloud architect? And they say, it's a different question. And I say, of course you could become a cloud architect. I used to be a nurse and a nurse practitioner. I practiced internal medicine before I went to become an architect. I can do it and you can do it too. It's a different answer. So that one misses the cache and I responded. Now that later 3 more nurses asked that day, the cache responds. So what we're dealing with caching is we're creating an in-memory environment that's going to take frequently accessed information and auto-respond by storing it in memory. That's it. So by comparison, let's think of it this way. Now, I'm not saying that people don't have to learn and work hard to build the skills. I'm saying it doesn't matter where you come from. We can all do anything we want as long as we get the right training and practice, and experience, and exposure, which we provide or you can get by knowing the right things to do. That's what I'm saying. So that's caching. So now think about it. If a website was hit 1,000 times a day and we had a cache, only 1 time per day would hit the website and the other requests would go straight there, meaning happy web servers. With databases, people often request the same information. So by using database caching, we can offload the work, the read load on the databases. So database caching is putting another server there, fill it with memory, and remember the frequently asked questions and answer them the same way each time. And that's what we're dealing with database caching. What happens? It takes the information, stores the memory, and answers future requests. What does the cache do? It makes the system more efficient. It makes the database scale. Imagine asking the same question 10,000 times a day and not only having the database answer it once and having the cache answer 9,999 times extra. There's that. Now you get it. That's why we use the cache. So with the cache, I want you to think of 2 things. If we keep the standard information that basically says as follows. If somebody requested pictures of my cat Cindy, guess what? If everybody else wanted to see my beautiful cat Cindy that day, they get the same picture. Now, if the next day I put up a new picture of my cat Cindy, and the cache was set for 48 hours. 24 hours later, they'd still be looking at the old pictures of Cindy. And let me tell you, Cindy's cute and still like to see her old pictures. But if you wanted to see the new picture and your cache was 48 hours, but there's a new picture every 24 hours, you got a problem, right? You're going to get old data. So we can set the cache to how long we want to keep the data based upon how frequently our data changes. One last thing to remember with caches. They don't always help. They can make it worse too, which is why when somebody says, Mike, what's the best solution? I say, we need to understand the problem. Most organizations will scale their databases through a combination of queuing, caching, and God, I'm drawing a blank on the name that I'm going to use right now. Read replicas. But if I've got Eddie Patrick that wants one thing, Marla who wants something else, Economy who wants something else, Alonzo who wants something else, Hand of God who wants something else, Z Skinfield who wants something else, Cisco UC wants something else, and y'all want something else. And they all have to stop at the cache along the way, and the information's not on the cache. The cache added latency. So the key that we have to deal with is the cache latency. So if the cache is frequently accessed information, woohoo, party time, scalability. If the cache is new information that adds latency, it adds an extra hop. So again, with architecture, we must understand the problem, the use of our data that we're trying to solve. That's why we can't answer things simply. How does the caching help? It offloads read requests from this database's servers or read replicas. Hence, it reduces CPU, memory, and disk I/O operations. When do you use it? For scalability, when you've commonly, frequently accessed questions, the same ones each time. Can I be a cloud architect? Of course you can. It all starts today. You learn this, you learn how to present, design, and sell, and poof, you'll be hired. And the next person that asks that, they can get the same answer. So caching will store multiple copies of it in a temporary location. Use it for software. We use it for all kinds of reasons. Now, what kind of cache do we typically use? We typically use a Redis cache. Redis is a persistent memory data store. It's an application that's designed to process huge amounts of application requests. It's optimized for distributed data or content caching, session stores, etc. It improves performance and scalability for your backend data stores. It keeps frequently accessed data in server memory. It provides low latency and high throughput. Supports OS, Redis 4.0, and 6.0. It's basically a Redis cache. Wait, if you wanted to run a Redis cache and not use the service, what could you do? You could stick it in a virtual machine and do the same thing. Same Redis cache people use in their data center. How are you going to add capacity to the stuff? Add a bigger cache, more RAM, more DRAM in your system. Same thing. It's just a big system with lots of it. Key scenarios. You're going to use the Azure cache as a data cache, a content cache, a session store. You use it for job and message queuing, distributed applications, etc. What's it actually look like in action? Here, I'll show you. You've got the browser. You're going to your WebEx. It hits the Azure cache. It's getting the response immediately. Doesn't even have to go anywhere else because the cache cached the answers to the stuff that was back here. So that's realistically what's going on. Apparently my pointer doesn't seem to work when I actually demonstrate it. I'm not sure why, but you can see the cache is storing things before it actually gets to the browser. Let's see where we go. I'm going to cover the database migration service, take a break, answer some questions, and we'll get to the next content. So let's talk about a database migration service. What is it? It helps you go from one database to the other. That's it. So a major cloud providers have it, and it's a tool that helps simplify and guide you to automate the database migration to the Azure stuff. Easily migrates your data, schema, and objects, fully managed and highly available. Migrates your data from data sources to data platforms. Everybody's got one, etc., etc., etc. For example, data management system is designed for business and data. Okay, so there's that. Now, while we're at it, let's talk about data warehouses. What's a data warehouse? A place to store huge amounts of stuff. Why do we store huge amounts of stuff? Why? To make better business decisions. So companies have something called data warehouses, often based on something like a Postgres, for example. Big, huge database to store lots of data. Huge database to store lots of data. So why are we doing it? Make better business decisions. Typically, a data warehouse is going to be the following. It's going to give us a big database. We're typically going to have a tool to store the data, a tool to visualize the data, map and reduce or prep the data, to normalize the data, kind of, etc. But why are we doing all this stuff? Remember, we're doing all this stuff so we can make better business decisions. That's why we use databases. What's a data warehouse look like? It's going to look like as follows. You'll see our data source. We ingest it, typically in object storage. We store it somewhere. Then we run an analysis tool. We could do some machine learning in here. We could use a tool like QuickSight, Tableau, Power BI, or something to visualize the data. And there you go. This database stuff can get a little tricky. So, what we'll do over here, if you guys want, is we can take a break, answer some questions. So let's take some questions from the group. On some databases, we'll talk about tuning and performance. We haven't gotten to half of that yet, but databases are a little complicated. So I'm not Mr. Database either, but I definitely want to answer your questions. Redis is in memory. Got a server that's got 2 terabytes of memory. Let's put it into a server that has 4 terabytes of memory. Now we scaled it. Good question, though. Almighty, I just realized these lectures have larger NA audiences than most popular colleges taught at your university, and you're learning 10 times as much. Thank you so much, Al. So far, we've had 878 people here today. I don't think it's enough. I want to get 10,000 people here. Please, everybody, make a tweet, a Facebook post, a LinkedIn post. So you can tell people to attend our free training. I want everybody getting cloud hired. They can go back and watch the yesterdays today too. So please share the word for us, please. I don't understand what DWH is. So I don't know if I completely answer you. You might migrate your information to object storage to import and output, but with databases, you're always storing your information in block storage. Now, why might we use object storage as a part of the storage environment? Remember from yesterday that object storage is a type of store network where you take your data and you break it down into objects, and each object has metadata. Now, that metadata is very specific, and when we create data lakes, for example, we often use object storage because the object storage has that metadata which enables us to query the data. But I don't know what DWH is. And Cisco, you said data warehouse, DWH is data warehousing. I don't use acronyms. I can give you 10,000 acronyms that mean 10 different things. When I was first a junior network engineer as a CCIE, 25 years ago, somebody called me at 2 o'clock in the morning and said, Mike, we're having trouble with the PVCs. And I said, give a lidocaine bolus of this dose and then start a lidocaine drip at this. And they said, what do you mean? I said, you just told me the patient had too many preventure ventricular contractions. When they were talking about permanent ventricular circuits. I don't ever use acronyms because they cause errors. And I can't have one person define somebody else's acronym, because while you're probably right, he could have been thinking about something else that you were, and you're trying to translate his thought in his mind. Appreciate the help, but that's why acronyms are so dangerous. And we architects can never use acronyms. And no, we see engineers do it all the time, but no acronyms ever in professional or executive communication. It's not allowed. And we'll be escorted out of the room and fired if we do in real life, trying to use an acronym with the CEO. So I just try to train you not to use them. Syncing database between reasons. There are no gotchas. There's no gotchas in syncing databases between clouds either. IP connectivity, IP connectivity. Make sure it's secure. That's it. There's nothing. Nothing. That's a good question. But it doesn't matter whether you're on the same cloud, different regions, et cetera, et cetera. You have a Postgres production database, which makes sense when you want a data warehouse. You move a blob not because you want it to rise to read many, you're moving it to blob because you want to be able to access that data and actually do something with that metadata. Because the database can't store its information in object storage. It can't use it. But typically the way this is going to work is we'll take our relational database, our NoSQL databases, our database warehouses. We'll have somebody on the big networking side write a Python Spark script to map and reduce it. We'll then take that and we'll create a landing zone, a place to dump in an object storage, and then we'll write another Python script on that to normalize the data. Then we'll catalog the data, and then we'll create our data lake. That's typically what's done. Actually, on our YouTube channel, hopefully some of Chris from my team or somebody else can post it. We had Praveen, who was a fantastic big data architect when he came to us. Now he's a working cloud architect, very senior cloud architect at JP Morgan Chase, and he's a fantastic architect. And he came in and blessed us and graced us with a nice 2-hour discussion on creating a data lake. And I think that would be incredibly helpful for you, economy, and for everybody else. If we can pop the link to that really good big data architecture discussion, I think it would be helpful for everyone. How is risk management captured from the baseline requirements in these configurations? You're asking a leadership question mixed with an engineering question at the same time, and they don't mix. You're asking an architecture question. Here's the architecture. What is the risk? What are we trying to protect? Is it proprietary information, meaning intellectual property? Is it customer information? Is it regulated information such as HIPAA or protected health, PCI DSS, etc.? So what is it we have to protect? What is the risk of losing it? Because we have to come up with a solution that costs less than the risk that the business is to the organization. So that requires an architect to have some really good business acumen to know, interview to find what the requirements are. After that, it's not the configuration, it's the design. It's the design of the people, the processes, and the technology. This is what architects do. We don't configure anything. There's engineers and admin people that do that. We design. So what is it? So for example, let's say I've got an encryption key. Let's say I've got some proprietary software that I'm coding that's worth $1 billion. That's the risk, right? Now, if this thing's worth $1 billion, let's think about that. I can't use an access list to filter it or some cheap web application firewall to filter it. I might need armed security at the edges of my data center. I might need the world's greatest next generation firewalls. I might need to do training of the people to make sure that they don't succumb to phishing or social engineering, for example. I might determine that I need 2 sets of next generation firewalls, followed by an IDS IPS, followed by an access control list, a security group. I might need a host-based firewall, some anti-malware protection. I might also need to disable unnecessary services on the servers. I might need to run encryption. I might need some strong IAM. I might need some few things. Medua, what determines those things? The business requirements. And that's why there's this massive disconnect between what the architect does and what the engineer does. It's not configurations at all for the architect. It's how do we go solve the business problem? Now, once we do this and build the architecture, and we tell the engineer, we need the firewalls to do this, the IDS IPS system to do this, the access controllers to do this, the security groups, hey, I need this person to harden an operating system. Then it's up to us to lead the team to do it. We don't have to know how to do their job. We have to know how to design it so it works. So you haven't given me the risk management problem yet. Now, if it's my cat Cindy's website, she's got a cat calendar, by example. And she's got pictures of her cleaning herself. She's real cute. Pictures of her playing with little lizards with her hands. Pictures of her chasing her tail and her cat calendar. Now, am I going to put $100 million in to protect this? No, she's a cat. Could I get away with a basic web application firewall and a network security group? Of course I can, because it doesn't matter. So how is risk managed? You have to determine the risk first. Only once you know the risk can you determine how to manage it. Whether, if you're a doctor, it's the same thing. How do you treat a patient with a life-threatening heart attack versus someone with a little cut on their finger, a boo-boo? So we have to ask the right questions as architects. And that's why architects and engineering are so different. And that's why we say certification helps you get an interview, but not hired, for the following reason. Certification is about the services that you can use. Architecture is about solving problems. But you still need to do the certification because it'll help you get the interview. And then you need to be trained for knowing what to do. Sure, Kenneth. Is object storage only temporary? No, you can use it forever. It can be used for long-term storage. If you need a data warehouse with both structured and unstructured data, well, data warehouse, structured data, unstructured data, no SQL databases. So the key is all businesses are going to have multiple databases. They're going to use relational databases for structured data. They're going to use data warehouses for large amounts of data. They're going to use NoSQL databases for unstructured data and scalability. And they're going to use object storage, and they're going to create data lakes and potentially machine learning environments. It's not either or. It's everything. Which do you need, an access list or a firewall? Both. Do you need a suit, a tie, and a jacket? Of course you do. So it's both. It's a good question. We'll talk more about data lakes soon. Good question. Very good question. Well, I'm not going to talk about specific databases like Postgres, but does relational databases scale better when you move the read and the write traffic? The answer is yes, and we're going to be talking about read replicas, etc. I'm not sure, economy. I'm a system designer. I don't really look at the data. But I do have big data architects that really focus on big data. But that's not me. I focus on end-to-end design. And I bring in big data architects to bring data where, because that's not me. As do all architects. Architecture is a team sport. I meet with the customer. I get a project. I come back and I say, I need 3 big data architects, 3 cloud security architects, 10 network architects, a cloud IAM architect, 3 DevOps engineers, 22 network engineers, and now we're going to do our proof of concept. And that's what it's like. It's team sport. Team sport. So we're going to get back to the concept. But before we do, please give me a hashtag, Azure Solutions Architect. Give me a hashtag, Azure Solutions Architect. I only see 117 likes. That feels like an awfully small number compared to all the people that are here. So give me some likes, give me some subscribes, tell your friends. Thank you so much, Abigail. Abigail has one of the cutest cats I've ever seen. Noni, one day Chris will bring the picture up. Her cat's amazing, and Abigail's amazing too. Good to see. I'm loving this. I'm looking at these names, and I see people in London. I see people in Cameroon. I see people in Atlanta. I see people everywhere, and I'm loving this. All right, so let's talk about serverless SQL port in Azure Synaptics. What does that mean? It's a query service that lets you query data in your data lake. It enables you to access your data through the following functions. It includes serverless SQL endpoints to query your data in a data lake, Cosmos DB, or Dataverse. It enables you to use TSQL syntax to query data in place without copying it or loading it. It's for large-scale applications, etc. Now we're going to talk about a data lake. What is it? It's a technology that allows you to work with big data to be able to analyze your data and make better business decisions. Why do we do all this? To make better business decisions. Why else would we bother other than to make better business decisions? That's the whole point. So we create data lakes for it's basically a data management system designed for business intelligence. It typically includes the following: a database to store the data, a tool to visualize the data, and a tool to prep and load the data. So what is it? It's really a repository of natural and raw data. It can be in files, it can be in blobs, which is object storage, because the metadata. What are the benefits of a data lake? Enables you to store your data, gives you schema flexibility, scalability, etc. Holds your data in native format. So in Azure, here's the thing. We've got, for example, the low-code options. Here we're using the Insights, Dynamics, Power BI, Microsoft 365. Simple stuff. But as we want to get into better systems for our data scientists and data user engineers, that's where you're getting involved into these kind of data syntaxes. So let me show you, if Microsoft would graphically represent it. At the high end, this is where your data scientists are living. But they're coding this stuff. At the low end, there's the kind of stuff that somebody like me would actually be dealing with, etc., etc. What's a data lake look like? Heck, let's look at it real quick. So imagine this. You've got a relational database here, relational database, data warehouse, and no SQL database. I also, and I'm not Mr. Big Data, but I know how this stuff works. This is object storage, right? Now you've got your data in a relational database, data warehouse, and NoSQL database. So let's say you've got Cindy the cat sitting in the relational database. Cindy the cat's in all caps in the relational database. Cindy the cat in the data warehouse is all lowercase. And Cindy the cat in the NoSQL database is spelled Cindy with capital C, and then everything else is lowercase. It's going to be hard to find all that data, right? So somewhere along the line, we're going to have to normalize that data. So typically somebody writes a Python/Spark script, and they write it and they take the data out of all these environments. And you also have data you store it in object storage, and you take your data coming out of something like this. So what you typically have is you take your data, you normalize your data with these scripts. That didn't look right. Let's fix this. So we take our data, clean up our data. Now we've got all this stuff stored in object storage, right? Well, that may not necessarily be the cleanest data either as it is. So we may need to take this data, let's flip it around. We write a Python Spark script. Now, at this point, we've got all this data that's clean, that's somewhat cleaned and normalized. We'd create another object storage environment, and we would more object storage. Now, I'm not Mr. Data Scientist. I'm going to make this very clear for you right now. And then what we would typically do is we would take the data from here to here and drop it here. We'll then take the data from here to here and drop it into there. We'll take the data from here to here and drop it into here. Then we'll take the data from here to here and drop it into here. Now we've got all our clean data in object storage. We probably need to, now it's all normalized. We typically need to catalog it. And then somewhere in here, and I am not Mr. Data Scientist, so this is a bit of an oversimplification. Here's your data lake. Now you got all this information stored in this data lake. And what can you do with this data lake? Anything you want. You want to go look at the data with a tool like Tabula? You can. Want to run some machine learning and get some actionable insights with your data science team? You can. That's it. So now you're seeing where the pieces and parts fit. So when somebody says, hey, what about this relational database? And I'm like, yeah, that's part of it. And when someone said, hey, what about this object storage? That's part of it. So the key is it's not an either or. It's let's take the pieces. This is what architecture is. Take this for what it does real well, and this for what it does real well, and this for what it does real well, and put it together. I'm told from people that they like chocolate chip cookies. I don't need sugar, or flour. But if I did, it didn't start out as a cookie. Somebody had to say we take butter and sugar and flour and chocolate chips and vanilla or whatever else goes into it and bake it. The architecture is taking all the stuff and combining it together where the end product is so good, it's so much better than the pieces and parts that go to this. It's the exact opposite of engineering. Engineering is as possible. How do I make this car go 2 miles an hour faster? What are the tech things I have to do? Architecture is determining, do we need a car, a plane, or a bus? And then designing it exactly for the business. Both are critical skills, but they're different. I hope this kind of solidified the why. So now that you know the data lake piece, let's talk about data shares. What are they? It's a publisher-subscriber-based data sharing tool. It offers snapshot-based sharing and in-place sharing. It securely shares your data with multiple consumers and partners. And it's easy to manage and monitor the shared data about time and by whom it was used. Pretty cool stuff. Now let's talking about right-sizing and optimizing your database. Well, let's talk about it. If your data is on a 120 core server and you need 4 of them, downsize it, use to a single server. How do you do that? You terminate it, start a new one. What if you're on a 4-core server and you need 8? Upgrade. No big deal. How else do you tune it? Well, optimize your firewall settings, right? Encrypt your data at rest. Check for misconfigurations. So that kind of puts pieces and parts together. So let's talk about the Azure Backup Service. You configure the backup. You start the backup. It runs a prescript, snapshots the virtual machine, runs a postscript thing, and it basically does your backup. Now, how is this working? It does an incremental backup. So here's what it is. Today, I back up everything. Do I need to re-backup everything tomorrow? No. Got a full backup today. What do I need to change between today and tomorrow? The delta or whatever the difference is. So today, I send the whole picture of the cat. Tomorrow, I show the picture of the cat where she moved her hand. The day after that, I show you where she put the hand in the lizard in her mouth. The day after that, I show you the gift that she left me on the floor. Incremental backup. I only need to send you the cat one time. Yes, my cat brings me way too many presents, and I've been asking her every day not to. But that's neither here nor there. Let's talk a little bit more about the Azure Backup Service. It provides a simple, secure, and cost-effective solution to back up and recover your data from SQL Server virtual machines, SAP HANA databases and virtual machines, database for Postgres. Point is, you got to back up your data. Let's talk about the Azure Database Backup process. We have to specify the server requiring the backup protection. Okay. And then the Azure Backup Service installs a workload backup extension into our server. The extension includes a coordinator and an SQL plugin. The coordinator is obviously responsible for triggering the workflows and various operations. And the plugin is responsible for the actual data flow. Now, to discover databases on the virtual machine, Azure Backup creates an account for the backup and restore. There you go. Let's talk about the Azure Backup process. Once it's triggered, you configure protection for the selected databases, and it will automatically just set it up. And the coordinator will communicate with the plugin at the time, and it'll begin streaming the backup data from the streaming server to the virtual desktop, and your information is going to be stored. What's it look like? I'll show you right here, right now. You've got your server. Your server has an extension into it, and it backs up to the Azure Backup Service. As you can see, your full backups, your incremental or differential backups are all encrypted by your key encryption keys. Okay, let's talk about transparent data encryption. There's lots of ways to encrypt your data, but certain databases, Microsoft SQL, Oracle database, the Azure SQL database, the Azure SQL managed instance, and Azure Synapse Amplificus work by protections to encrypt your data at rest. Meaning, once it is stored. What transparent data encryption is, which I love, it encrypts your data when you store it and de-encrypts when you receive it. So it's constantly encrypted when you need it and not encrypted when you don't. Talk a little bit more about transparent data encryption. It works with something called the key vault, and it's a configuration of data encryption. It encrypts and decrypts your data on demand. When the data is written to storage, then it is encrypted, and it is decrypted when it's removed from storage. And the key vault is basically a hardware device that's going to store your encryption keys. So let's talk about Azure Database Scalability. An important characteristic of a platform as a service is that it expands dynamically when you need it. Hopefully. Architecture of the platform can be scaled up, meaning add more systems. Scaled up, adding bigger systems. Scaled out, or adding more systems. Now, when we're dealing with databases, it matters. Scalability matters. So we can scale up to the world's greatest server, right? What happens when you exceed the capacity of the world's greatest server? So at some point you can scale up, but at some point it's not possible. You're going to need to add capacity and you're going to need to scale up. So let's think about it. What is an Azure Read Replica? An Azure Read Replica is a read-only copy of the database. MySQL Read Replica, PostgreSQL, same thing. With the Azure databases, the standard databases, you can replicate to up to 5 read replicas. And the updates are asynchronous. And this is going to be used for offloading. So what we're going to do is I'll go through these things, and architecturally, if you want, I'll put the pieces and parts together to show you how it works. So here's the way this works. You've got your SQL server. You can add your read replicas, and you can also add a couple. You can stack them should you need them. Here is your master database where it says SQL primary. Everything else is a read.
Are you sharing your screen?
I thought I was. So you can see we've got the SQL primary, which doesn't show up very nicely because of the pretty teal colors that we used, and my green screen in the background. So you can see you've got SQL where it says primary, and all the other readers are there. So why do we do this? In databases, we got a combination of read and write. So what is it? Somebody buys a cat calendar for sending the cat. It's a write to my database. Now what happens? Abigail wants to see a photo of Cindy the cat, and she sucks it out of the database. It's a read on the database. Now, most websites have a lot of database reads, often 4 to 5 or 6 times more than the writes. So now, in my database, I got a photo of Cindy. Cindy's a very beautiful cat, by the way. And Cindy does something really cute, and I decided to post it on LinkedIn with our 15,000 followers, on YouTube with our close to 30,000 subscribers. I email it to a massive number of people, and everybody wants to see the same photo of Cindy the cat. If I don't have a read replica, all the requests for beautiful Cindy the cat go to the same server. And the server responds, right? Now, at the same time where the server's responding, I'm dumping a bunch of photos of Cindy back in the database. And I'm trying to write like 1,000 new photos of Cindy, and everybody's trying to read the Cindy photos. Well, the database gets busy. I can write a certain amount. I exhaust my hard drive. I exhaust my memory and CPU. Database crashes. Good. Now, what could I do? I could stick 4 read replicas and say, anybody that wants to see photos of Cindy, go to the read replicas. They'll answer you. And all I'm going to do is the primary database is write. So there's that. So I hope that makes sense to you. Now that's read replicas. Let's talk about queuing. Queuing is just a place to store your messages. So if you go to the airport and they say form a queue to get onto the airplane, why do they do it? Well, if they didn't, everybody jump on the plane right now. We'd all be running to the plane. We'd be knocking people over and we'd be fighting in the door. Please form a queue or get in line, what they'd say in America. In England, they'd say, please form a queue. You get in the queue, the line. They let the first class in and the elderly people. They let the people in the back of the plane, the middle of the plane, the front of the plane. See, it's organized. Why do they do that? They don't want everybody, get out of here, get out of here, get out of here, just so they can get on the plane in a hurry. That's what they're doing. So keep that in the back of your mind. What is database queuing? It's a means to take messages, store them somewhere on the way to the database. Why would we do this? Okay, right now, think of it all. Everybody wants to order the sun cat calendar of Cindy the cat. Boom, boom, boom. The database can't handle the volume of reads or writes. So it loses half of the orders. Now, my cat Cindy, who wants to sell her cat calendar, is not going to be happy if she loses orders. She's going to bite me and scratch me, and she's going to be very unhappy. And then I'm going to be unhappy, and I'm going to be explaining it to my wife, and that's going to be even worse. Why the cat scratched me? Because I didn't take care of her. Don't want to do that. So by comparison, if I could take all the orders, stick them into a box, and when the database is ready, take the orders from the box and stick it to the database. That's the form of a queue, so we don't lose messages. So a queue is a place to store your messages until the database is ready to receive them. We stick the message in the queue completely unprocessed. I took the message from the queue, take it out of the queue, pop it in the database. Simple, simple, simple. So a queue is a mechanism to store the databases. Sender sends a message, the queue holds them until the receiver is ready to do it. So with Azure, we got 2 kinds of queues. And of course, you could make a Kafka queue or do other stuff if you chose to. We've got the storage queue and the service bus queue, and we'll cover both. What does it do? So it's a place, the storage queue enables us to store messages, millions of them at a time. So all of a sudden, we got lots of orders from my cat Cindy's beautiful cat calendar, stored in the queue. She doesn't lose any. Cindy's happy. She's rolling around on her back, chasing her tail. She's purring. She's eating her shrimp, scallops, and salmon, and she's all kinds of happy, which is the way I like my cat Cindy to be, all kinds of happy and purring, the way it's supposed to be. So basically what happens, the queue can hold messages up to 64. The queue provides a uniform and consistent programming access model to queues, tables, or blobs. And it's really optimized to create a backlog of work to process asynchronously when it's there. Now, unless you select the option, there is no guarantee of the queue. Messages come in and they get drained out as fast as they can. Now, if you need message 1 drained, message 2 drained, message 3 drained, or a first in, first out configuration, for those that are familiar with that from queuing or the accounting term, then we use a different kind of queue. We use the service bus queue. And what is this? This is a service that supports queuing, publishing, and subscribing. It's optimized to integrate applications or application components spanning multiple communication methods. It provides support for local transactions. So let's actually look at this kind of stuff. Here's what it's going to look like. We're going to have we have our web server, it hits the app server, it hits the queue, and then it goes to wherever it needs to be, like the database. Just a place to hold it. So let's talk about Azure Data Factory. It's a technology that orchestrates and operates processes for refinement and storage of enormous amounts of raw data. We use Azure Data Factory to help create actionable insights. Meaning, what kind of stuff can we do with this data? We're not just collecting it for no reason. It contains a series of interconnected systems providing an end-to-end platform, and it's optimized for scale-out serverless data integration and data transformation. And using their terms, not mine, single pane of glass, meaning it's easy to understand. Let's look at it this way. You've got your on-premises information, got your cloud, and it's finding a way to basically help you make sense in heads or tails of your data. So let's do this. Let's whiteboard out how to make it happen. How do you scale a database? Because I just told you all the certification stuff. Now let's talk about reality. So here you've got a database. It sits on a server. Let's build this out. I want you guys to get it. So we've got over here a beautiful relational database. Let's say it's MySQL. I don't care. It doesn't matter which one we're going to use. We use a database. I am the database. Make it a happy database. Okay, so I didn't make the smiley right. Okay, so now we got a happy smiling database. Now, right now, here's what happens. All read traffic and all write traffic goes to the database. So here we go. This is Cindy's database. She's happy right now. She's selling 4 cat calendars a day. It generates $20 for her, and she buys $10 of shrimp, and she's saving $10 a day for the brand new cat tree that she desires. She's all kinds of happy. Cindy gets what you want, but whatever. Now, out of nowhere, Katy Perry, who loves cats, and Taylor Swift, who love cats, say, hey, everybody, Cindy the cat's got a beautiful new cat calendar, and you got to go see it. And now Cindy's trying to get the orders and relate, and she's like, oh, my God, I can't do this. I'm chasing my tail. It's too much. So Cindy says to me, she's like, I need some helpers. So the first thing that I do is I get Cindy some read replicas. And here now, here's our read replicas, and here's what they do. Now, in this per situation, we've got a read replica, we've got a read replica, we've got a read replica. And now, every time somebody looks at Cindy's cat photos, does this, or any cat photos that she has, they go to the read replica and not her main database. So now, all Cindy's database has to think of is all the orders that are coming in from Katy Perry's and Taylor Swift's social media posts. So Cindy's really happy. She's doing half the work. But here's the thing. Katy Perry's and Taylor Swift's Instagram following are so big that the read replicas can't answer enough questions. So what do they say? I need a vacation, Mike. I need more help. Can you help? Everybody is asking the same silly question. They all want to see a photo of Cindy chasing her tail. It's all day long. All of us are doing the same photo. So now here's what we do. We add the cache. Let's call it a Redis cache. And now, everybody that wants to go see the photo of Cindy chasing her tail hits the cache and gets the response. And new requests that are not seen by the cache hit the read replica. Now, Cindy the cat is good. Life is good. And then, out of nowhere, Cindy the cat receives the Presidential Medal of Honor for something. She's at the White House. She's now on CNN, MSNBC, and Fox News, CBS, and NBC. And now everybody wants to buy Cindy's cat calendar. Do you think Cindy can handle the messages for this? Absolutely not. Cindy's going to be totally lost. So here's what we need now. We need a queue. And whether the queue is a Kafka queue, an AWS SQS, a message queue, which we just talked about, we need a queue. And now when Cindy receives that Presidential Medal of Honor, all the right requests hit the queue. They sit in the queue, and when Cindy's ready to see it, she says, thank you. New $5, new ball of shrimp. Thank you, new $5, new ball of scallops. Thank you, new can of tuna. I'm all happy. So that's how we scale databases. I hope this made sense to everybody. Now, at this point, let me answer some questions. And actually, before we do, let's talk a little bit about high availability networking design, and then I'm going to open it up for some questions. When we're dealing with high availability access to the system, let's talk about what is high availability. It means making sure your systems work when you need it. Okay. That's what high availability is. If you need your systems and you can't get them, they're not available. Now, with Azure, they've got multiple high availability architecture models for the database. There is the standard availability model and the premium availability model. In the standard availability model, there is a separation of the compute and the storage. And so there's that. And then the standard model, there's a reliance on high availability and reliability of the remote storage tier. So good servers attached to the network. The network goes down, you lose everything. The standard availability model is excellent for budget-conscious individuals and applications. It's optimized for people or organizations that can tolerate performance degradation during maintenance. Can Cindy the cat tolerate it if she's not on Katy Perry's or Taylor Swift's list? Of course she can. She's selling cat calendars. Standard availability model. Now she's receiving the Presidential Medal of Honor, and she's everybody's social media darling. No, she can't use the standard availability model. So keep that in the back of your mind. Then we have the premium availability model, and that's based upon a cluster of database engines. And this is designed for your systems that have mission-critical, high I/O performance requirements, for example. That's what we're dealing with over here in these particular environments. High transaction rates with guaranteed throughput and minimum performance. And that's what we're talking about. Now, how do you make it better? Well, zone redundancy. So if you've got your database in a data center and the data center dies, and it's not in another data center, it's dead. So what zone redundancy is enables you to put your database in multiple availability zones. And it's load balanced with DNS. So your primary and secondary radiuses are good. Now let's think about this. Your database is in multiple regions, multiple availability zones. And the Azure cloud gets hacked. They have a network outage, or the control plane gets hacked or goes down. It doesn't matter how many availability zones you're using, how many availability regions you're using, you're still dead. And that's why you should always use a hybrid cloud or multi-cloud. But architecturally, what does it look like? With multi-zone, you got your databases spread throughout data centers. And that's it. And as long as the Azure cloud is up and working, you're good to go. You'll be up and fully operational. So let's open it up for some questions right now. I'm sure I covered a lot of stuff. How long do you have access to the Azure Labs? Well, you'll have plenty of time with those Azure Labs. At least 6 months or more. We're not in a rush to take them away from you. All I care is that you guys build your absolute best career. Good question. Who else has a question? You don't have to be shy. I don't bite. I just want to help you all get the best careers possible. Sharon, here's the good news. I did not make that diagram. That is actually a diagram that we created to make it look and feel like the way Microsoft actually does it, which is not exactly the way I like looking at it because it would make me dizzy too. Can I go over read replicas versus a cache? Sure. A read replica is an exact read-only copy of the database. An exact read-only copy of the database. A cache offloads frequently accessed information from either the database or the read replicas. It's just a big memory store. Good question, though. Nick, could you please give me some real-time example when you should be using a Kafka queue? I would use it in every database architecture in the entire world. So here's the way I see it. Got a web server, right? Some app servers, right? And a database. If I decide to send the information to the database and it's overwhelmed, I need a queue. So I got a choice. I can use an SQS queue on AWS or an Azure Service Mesh queue. I'm never going to use that ever. I'm always going to use a Kafka queue. And here's the reason why. I think you're crazy, or anybody would ever be crazy, not you, to ever put all your eggs in one basket. I wouldn't put all my money in a single stock. I'd diversify my portfolio. I wouldn't build a WAN on the same company, and I would never stick everything in a single cloud. I'm not insane. Now, I've advised customers for the last 25 years never to use a single service provider. Great companies like Cisco tell companies never use a single service provider, and they decide to do it to make it work for a reason. So the second I use an AWS SQS queue, or an Azure message queue, I'm using proprietary stuff, which now makes it harder to go from AWS to Azure. Since 87% of customers are multi-cloud, half of the stuff and certifications like the message queues, I would just throw out in the garbage. I wouldn't use the Cosmos database either. They're great services. They're terrific, but I'm now handicapped to Azure. What happens if Azure raises my rates? What happens if Azure is like AWS, where they kick Parler out because they didn't like their business? I can't let my whole business be bankrupted by a cloud provider that's willing to kick me out because they don't agree with me. So I will never design a system, unless the customer wants me to, that doesn't use an open standard. A Kafka queue is an open standard that I would use in every single architecture that needs a message queue. Always use it. So I don't think there's a time where you're building a database where you shouldn't use a Kafka queue. Unless there's some reason that you've determined you're only going to go single cloud and you're training availability for cost or agility. So in every architecture, I would use a Kafka queue. So here's the example. I would never, ever, 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 ever use SQS because it's proprietary. I would 100% of the time use Kafka. I often don't say ever or never. I don't use proprietary anything because I don't believe in single cloud solutions. So I would never use SQS. I would always use Kafka. Good question, though. Cat writes, now explode, no more say. Say you have MySQL and you can only scale it vertically. MySQL, you can scale horizontally by adding read replicas, caches, and queues. So that's not actually true. We would do the same thing with MySQL as we would with any of these things. Read replicas, caches, and queues economy. No problem with MySQL. You can scale it vertically and horizontally. Almighty, you're putting it together now. Exactly. Can you explain how and where the load balancer will implement it? Yes. We would put a load balancer in front of the web servers, a load balancer in front of multiple app servers, but never do we use load balancers with regards to databases. You like the Cindy diagram better? I like the Cindy diagram better. But believe it or not, I actually had a professional graphic artist design that, and we wanted to make it look closer to what other people provide, just so you could say the difference between Mike's square little happy boxes and professional documentation. But no, you can't have a primary database be Cassandra and your read replicas be MongoDB. First, K-Toddy, no SQL databases don't use read replicas. So Apache Cassandra doesn't do it. Apache Cassandra uses as many servers as you want, and it reads and writes to all servers. MongoDB is kind of the same thing, but MongoDB doesn't write to every server the same way. So Apache Cassandra, much better for high read traffic. MongoDB, much better for more write traffic. Do read replicas get updates in real time as well? Yes. So when you update the main database, the read replicas get it. Read replicas do not do write requests unless you promote a read replica to be the lead. I've not worked with database proxies. I've worked with caching, read replicas, and queuing systems, as we've described today. Path to be an architect. What programming language do you have to learn? Tyson Lee, architects don't code, ever. So there's no programming languages you need to learn. And that's why we have our Cloud Architect Career Development Program, because most people that want to be cloud architects learn Linux and Python and Terraform and SysOps and DevOps. We don't have any of that in our career. So I'm going to invite you to the webinar tomorrow to learn more. The cloud architect does the following. We design, we present, and we sell. A cloud engineer codes and configures, but an architect designs, presents, and sells. Now, what are we designing? And I really want you to come to my free How to Get Your First Cloud Architect Job webinar. We design network and data center stuff. What is everything we talked about so far? Network and data center technology. So what do you need to learn? BGP and how to design it, interior gateway protocols such as OSPF, IP addressing, subnetting, and supernetting. It involves learning DNS, DHCP, ARP, proxy ARP, etc. It involves WAN protocols such as SSL VPNs, IPsec-based VPNs, Ethernet private lines, serial private lines, Ethernet over MPLS private lines, BGP 25, RFC 2537, cloud/VPNs. It involves learning software-defined networking and SASE. It involves switching, which means VLAN tagging, VLAN trunking, spanning tree, rapid spanning tree, etc. It involves NAT, one-to-one NAT, one-to-many NAT, static NAT, dynamic NAT, PAT. Now remember, we don't touch the tech, we design the tech. Now next, you have to understand these data center technologies, servers and server virtualizations, containers and container orchestration, block storage, object storage, file storage, load balancers, when to use them, how to architect them, how to design and work around them. What kind of databases to use, how to scale the databases to use, what kind of big data applications can make the businesses make better business decisions. Firewalls, next generation firewalls, IDS, IPS systems, for example, Active Directory, Radius, and other types of authentication, authorization, and accounting systems to get people in your systems. That's the tech stuff you need to know. But remember Tyson Lee, this is your job of design, present, and sell. So this job is a business executive's job. So that must mean you must have CXO relevancy, which means if you're not training for it, you won't be hireable. We have a training program we can train you. It involves sales skills because you're going to be selling things that are upwards of $1 billion constantly, and you're going to have to produce an ROI model, return on investment capital, to show the customer the cost of your solution is more than mitigated by the business value that it receives. You'll be presenting to audiences of 3,000 to 5,000 people constantly, so you're going to need some expert presentation skills. You're going to be presenting to executives that are going to be visionary, like me, analytical, like my COO, or process-oriented. You've got to speak to them in different languages because they speak different languages. As an architect like me, you'll be constantly in newspapers. Chris, we just posted another magazine article today about our Helping Our Heroes file. Maybe we can show this. So you need to be used to that. Now, you must have gravitas or executive presence. What does that mean? Today, we talked about relational databases and adding read replicas. That's without gravitas or executive presence. You need executive presence training. I have it. We train in our course. Today, we're going to talk about databases, relational databases, how to design them and how to scale them. Feels different, right? You need that. Now, Tyson Lee, you're going to be managing upwards of 50 cloud engineers on a standard project as a cloud architect, so you're going to need some leadership skills. Now, you're also going to be negotiating deals upwards of $1 billion, so you're going to need some negotiation skills training. That's what you have to learn. We don't code, we don't touch the tech, we don't configure. Please come to the session tomorrow, and I'll tell you everything that you need to learn to do, how to get your first cloud architect job. We can easily get you hired. We get people hired every single day. Just yesterday, 2 of my students told me they got up for their first cloud architect job, and they weren't the people that were on the presentation last night, just 2 more of them. So now you know what to learn. It's not a hands-on tech job. That's engineering. This is architecture. Very different. Half executive, half tech. Chris, you can go to the next one. In case of any downtime, note, read replicas do not do reads. They only do write. No, all of our databases and read replicas have to be of the identical family. But like I said before, no SQL databases do not use read replicas at all. Okay, so it seems like we had some fun time. Tomorrow, we're going to start with my favorite topic, networking. And it's going to be basic networking because we're dealing with an Azure Solution Architect expert networking, which is relatively basic. But guess what? Guess what? Here's the cool stuff. I'm also inviting you to a completely free BGP session, which will be about 4 hours, and a subnetting session next week, which will be about 4 hours, all live and free. So sign up for that. Make sure you join us for the How to Get Your First Cloud Job webinar. Look, I've been helping people get their first job for more than 2 decades, 20 plus years. And every day I see on LinkedIn some of the worst advice. Get these certifications and waste a year in this thing, and then you won't be hireable. I know how to get you hired for any kind of job you want. And I'm going to tell you how to do it completely free tomorrow on the How to Get Your First Cloud webinar. I want you hired. And here's the thing. The average cloud architect earns $600 a day. A good one earns double that easily. And a good an average cloud engineer earns $500 a day. A good one can earn much more than that with the right business acumen, leadership skills, emotional intelligence skills, sales skills, executive presence, etc., etc. So this stuff is really, really critical. Hold on a few minutes. We may have something for you, but there's kind of that. It's very, very critical for you to know the job and prepare for the job and the job that you want. I want you all getting there. So make sure, Tyson Lee, you're an engineer in the network and the data center. Good. So I want you to understand the difference. A network engineer does router BGP 65312, neighbor 172.168.1.1, remote AS 65313. Neighbor 192.168.1.1, remote AS 65314. Neighbor 1.1.1.2, remote AS 65312, the same one for our IBGP peers. Now, maybe we had a network statement 172.168.0.0 mask 255.0.0. Okay, neighbor this, activate. Okay, that's our BGP configuration. That's what engineers do. We do none of that as architects. What we do as architects, Tyson, is as follows. What does my IBGP routing look like? Do I need a confederation? Do I using route reflectors? Am I fully meshing my peers? Okay, I've got 8 eBGP peering sessions. What am I going to do? Am I going to leak a more specific subnet over this one? Am I going to prepend the AS for this subnet on this one? Am I going to change the weight on this one? Am I going to match a community, tag a community? So the architect, so think of it this way, Tyson. Think of a network architect. And that's really what the cloud architect does. Someone that's architecting the network and the data. So never touching the technology, no code, no configure. So it's going to be someone like me. So my CCIE number is 7417, back when it was a hard exam before they made it easy and made it a single day exam. It used to be very hard. It's still not easy, but it used to be a miserable exam. I had to read 75,000 pages of reading for it. Now, in that CCIE exam, I configured it. Now, in the CCDE exam, the Cisco Certified Design Expert, it's design. So architects design, present, and sell. And Tyson Lee, when I was a network engineer, and I wasn't a network engineer long, I moved into that architecture world. I had a manager that told me the following lesson. And it was like a big thing. I was forced to take some boring certification boot camp. It was this 5-day CISSP boot camp. Like 5,000 of us took it, and all 5,000 became CISSPs by the end of the week. It was a nothing exam, nothing boot camp. But that's the thing. Certification's easy. And I fell asleep, but my manager pulled me out of the boot camp, and he's Mike. He says, he's like, you're not like everybody else. And I went, uh-oh. I just fell asleep at a boot camp. Am I getting fired? And my manager says to me, he's like, I got to talk to you. He says, you're not like the rest of these people. He says, they want to code. They want to configure. They want to get techie. He said, you're already maxed out on your tech. He said, you get another certification, no impact on your salary. You learn more tech, no impact. It's no difference. He said, Mike, and this was 20 years ago. He said, you know the difference between a $150,000 sales engineer like you and a $300,000 enterprise architect like you could be? And I was like, you got to tell me, please. And what he said, business acumen is the impact you can make on your customers. It's your leadership skills. It's your sales skills. It's your emotional intelligence. It's your ability to be relevant, to say what the CEO, what he cares about, versus the CTO, what they care about, versus the CFO. It's your ability to do a proof of concept and bring in 100 engineers and lead them. It's your ability to speak at a conference with 5,000 people in it. It's getting you in magazine articles, et cetera, so the world can see what your solutions are and how they can shape the world. There's that kind of stuff. That's what they told me. So that's what I actually got. So my manager said this. Now, granted, I received about $250,000 of training in these special skills. Lots of presentation skills training, lots of sales training, lots of ROI modeling training. I also did it in the MBA while I was at it. And when I learned these $250,000 skills, instantly, I was no longer a $150,000 engineer. And that was 20 years ago. 20 years ago. And since I've spent 20 years helping people optimize their career, what do you think I've been helping people do? Giving them the tech skills to succeed, and then saying, hey, wait, your tech skills only get you 30% there, 40% there. If I can teach you these other skills, your career will be up here while everybody else's career is down there. And that's exactly what I've done. Exactly what I've done. So that's when you're asking me these architecture questions. I'm going to tell you right now, nobody gets hired as an architect because they're a techie. Nobody. But everybody gets hired if they're good. And that's really the key. So actually, right now, we just released a new magazine article. And we're going to post it. I want you guys to see it. And hey, maybe you guys can comment, and share this. I write it like 2 to 3 magazine articles per week. This was an article written about us and what we're doing to help our warrior community. And let's be fair, I love our warriors. I tried to enlist in the Marine Corps at 18. It didn't work out my way. I did spend years as a firefighter, paramedic, and assisted the tactical community in many ways. So I'd love you to see what we're doing to help the military community, et cetera. And we would love to work with you. So my team posted it out there. I'm going to share that link with you in the chat box. Please like it. Please check out what we're doing. So Chris, go ahead and post that link in the chat box, so you guys can all see it. And then after you guys see the link, read the article. I want you to let's check out that article for a minute. See that article. So we want to help you reach your maximum careers. Miguel asked a great question. How do you be comfortable with technical questions and answering them when you're fairly new? Great question. So Miguel, if you've got the real skill and you truly understand it, it'll be very simple. So with my students, I make sure they understand it in depth. See, we don't configure. And Miguel, if you spend your time learning how the tech works, what the tech does, and how to utilize this technology, here's what's going to happen. You're going to get hired and be able to answer these questions. By comparison, if you spend all day configuring things, and I ask you, hey, you've got 2 equal cost paths to the cloud over two private lines with BGP. How do you share without getting load share without getting rid of the packets? And you're like, I can configure it. And I'm like, yeah, so how do you design it? So I think it's knowing the difference between design and implementation. Once you learn it, especially my students, if you learn what is the tech, how does the tech work, and why do we use it, it becomes burned in your memory forever. And when you truly understand the content, it's very easy to get. When you deal with one of the certification providers and you listen for 1,000 hours and you don't understand it, I'm going to tell you right now, it's because none of them have ever been cloud architects. And they don't know the tech which you're trying to teach. And if you don't know the tech, it doesn't come out right. So you have to know it like the back of your hand. And that's when you'll be able to do it. So Miguel, feel confident in yourself. You're going to do fantastic. Go out there, do the job, learn the job, master the job, and then go build the career of a lifetime and tell me when you're cloud hired, Miguel, and tell me when you're promoted, and watch the magic that's going to happen. Practice, practice, practice. I used to record myself. What is the tech? How does it work? Why do you use it? And I did it for everything. And I made sure that I was satisfied. And when I could do that, I went on an interview. And then I got hired. So I strongly encourage all of you to join me tomorrow. All of you. On the completely freer. The cloud providers all give basic architectures as part of the interview process. So nobody cares about certifications. I get people hired all the time, economy without certifications. No one cares. You got to go in an interview. You got to design an architecture which is not covered in any way, shape, or form in certification. You got to sell that architecture back to them. There's a leadership interview, a behavioral interview, and a sales interview. Nobody's going to ever ask you to configure for an architect or code, but they won't want to know that you can design. Thank you so much for the fantastic article, Scott McCormick. The veteran community is so critical to us. Please, everybody, see that link, that article we wrote. We posted it to LinkedIn. This one's in one of the Miami news magazines. Like I said, we're in 2 to 3 magazines a week. They're always writing about what we do to help people get hired. But I thought you guys could enjoy this one because the military community is so special to me. So this is going to conclude day 2 of the Azure Solution Architect Expert Training, our free Azure training, our AZO 305 Azure Course, day 2. So what I would ask you to do is as follows. Please give me a hashtag cloud hired and a hashtag Azure Architect. And if you're not a subscriber, please subscribe and hit the bell. Follow us on LinkedIn. We're there every single day. And we are thrilled to have you here. Sign up for the Azure Lab videos so you can do the labs on your own time. I let you get some hands-on experience as well. Sign up for the Azure Bootcamp. Your own part of it. Sign up for the networking work next week, the BGP workshop. And when you sign up for either the BGP workshop or the subnetting workshop, you'll get invited to both. If you haven't given us a like, please give us a like. Please give us a comment, etc., etc., etc. Please give us a share. And please, everybody, we spent a lot of money to put this together, a lot of time. There's 6 of us, my team, working. Please share this. Tell others to attend the free training. Send them a link. Make a tweet, a LinkedIn post, a Facebook. Post it to a group somewhere. I want everyone from LM in Mozambique to Eddie, who's in Cameroon, to Leo, who's in Sao Paulo, Brazil, to me that's in Palm Beach, Florida, to Alonzo that's in Dallas. And everybody that needs access to training, get it for free. Not everybody can afford it, so please help us share the word of our free training. There we go. We've got somebody from the Sudan. Isn't this amazing how wonderful it is? And also, while you're at it, tell me where you're at. I'm in Port St. Lucie. There's still 170 left over. Where are you? I love knowing where people are at. I love doing these free Azure Solution Architect boot camps. Who knows? We may do another free boot camp too, very soon. Emi's in the Netherlands, raised in Daytona Beach, Birmingham, UK. Currently in Miami. That's pretty cool, Perez. Pennsylvania, I lived over there. Manchester, UK, that's where my name Gibbs is from. California, Tom's in Netherlands, but I think he's Ellenis, but that's neither here nor me. We've got somebody in Toronto. I'm loving this. Oakland, California, Atlanta, Berlin, Leonardo. I'm assuming you're from Brazil first with that name. Brandon Bowman's in Atlanta. Thank you for your service, Brandon. Hoorah! Appreciate everything you've done for our safety. Dallas, Texas, for Ron Miller, Bay Area, California, AJ, hoorah, and thank you for your service. IT Pro in New York, Manchester, UK, Alonzo's in Katy, Texas. Abigail, I saw your Blue Ranch, I think. Thank you for your service as well. Ash Winnie, Azure Architect, Sheridan is in Chicago. Sanat is in LA. And Brandon, Brandon has done so much for us. Hoorah. And Pawan is from India via the way of UK. Kazakhstan, I'm loving this. Las Vegas. This is amazing. Yeah, I do try and make it a little lighthearted and fun. Atlanta, oh my God, I love this. Just love it, love it, love it. Miguel in Philly. I actually went to Temple University. I lived in Northeast Philadelphia for years and even went to Widener University and Drexel University. So that's a place I know real well. Went to Temple University undergraduate too. Yeah, please see our recent article. Please, I want you to all to see this. I knew you were Brazilian with that name. So Leonardo, right now, we now speak English and Greek with me, Portuguese and Spanish with Leo, Vietnamese with Chow plus English. Eddie speaks English as well as French, which I find really cool now. And there's a little Japanese on our team, but we don't talk about it that much because Alonzo's a little uncomfortable with his Japanese. But that's the key. We're a pretty international team here. I used to be able to speak fluently in Spanish and take my way through Arabic, but that's been a long time ago. I can't do it anymore. But it was one of those things. So thank you all. I hope you guys had a great time. Can't wait to see you tomorrow. We're going to have fun, fun, fun. Get the Azure Lab demos. Sign up for the free networking next week. And by all means, please join us for the How to Get Your First Cloud Architect Job webinar. We get our people get hired every day, and we want you to be there too. Your cousin graduated from Temple. Wow, I probably went to school with her. And yes, we love this. And in Boston, I love it. I love it. I love it. Bob, Tracy, thank you for our team. Thank you all. Alonzo says, thank you for attending, everyone. Have a wonderful, wonderful, wonderful day. And please tell a friend to join us. Take care.